Hello guys, a very good morning everyone. Welcome to the session and welcome to the discussion of ISRO 2020 Electronics and Communication complete question paper with the entire solution. Yes guys, the last paper of ISRO that was conducted was back in 2020 and this year again they have come back with the huge announcement. Yes, okay, it's approximately 350 vacancies have been released, 96 for electronics out of them. So yes, and we are going to discuss the complete paper of 2020 ISRO. Okay, so come on quickly everybody, share the session, let every student join and let's get started quickly. Let's get started quickly. Yes, just a moment. So you know that the ISRO paper in 2020 was purely technical including mathematics, but there were only 2 questions of maths. Okay, and there were total 80 questions as per the previous ISRO pattern. So we're going to discuss in this particular session one by one all those 80 questions. Yes, all those 80 questions guys are going to be discussed, so stay tuned with us. Okay, one by one, me, Ashu sir, Sanjay sir, Saket sir, we're going to come up and discuss up all the particular questions. So let's get started here. Okay, with the first question. Okay, just a moment. Yes. What is this guys? Okay. Right. Very good morning everyone. So let's move ahead. It's okay now. Yeah. Okay, thank you. So yes guys, okay, finally starting up. यहाँ पे ध्यान देंगे. But yeah, before I start up the first question, okay, a very important update for all of you. You must be aware if you are subscribed and updated to the channel. Yes, the Trickopedia is now live. Okay, from the 15th June, that is yesterday. Trickopedia, the dictionary of tricks. Okay, the shortcuts. Okay, the crucial pointers, the crucial approach that is going to help you, ace the gate examination in very quick amount of time, in very quick manner. Yes, okay, how to approach the questions, what are the tricks, so there are several tricks that can be, applied in the questions that is coming to gate examination. So every day you're getting one video, a small video, maybe 3 to 5 minutes, and you're learning one particular trick in that. Okay, chalo guys, so subscribe to the channel if you don't want to miss any of these activities. And now let's get started here. Okay, with the first question, that is from mathematics. As I told you, only 2 questions were there from mathematics. After that, let's move to the core area, the technical area as well. Okay, and quickly keep sharing the session to all your friends. Okay, evaluate integral x power 4 fx dx, where fx is 1 upon root 2 pi e power minus x square by 2. Okay, let's start with this particular function, x belonging to minus infinity to the infinity. A type of Gaussian function is given to you. Okay, but it's not going to be actually related with any normal distribution or Gaussian calculation. We can directly solve it up, and to solve it up, let's see the integral. Okay, let's quickly discuss this. So integral is the integral of the form x raised to the power 4 fx, right, and that is 1 upon root 2 pi e raised to the power minus x square by 2. Right. Okay, now if that is the case, what I'm going to do, I'm just going to start by putting x square by 2. Okay, we just convert this, put down the x square by 2 equal to some variable t. Okay, some variable t. So what is going to be the value of x square then? X square will be 2t. Accordingly, we will put the value of x as well. Okay, so if I put down in this integral, it is going to be, x square is equal to t, right? X square is equal to t is what we are going to put. But before we put that, okay, let's have an observation, otherwise the integral will not be valid here. देखो, यहाँ पे क्या हो जाएगा? You have the integral minus infinity to infinity and you have an even function. You have what? You have an even function, x power 4 and x square. Both the terms are even. And for even function, first of all, let us apply the quick result that this can also be written as twice integral 0 to infinity. Okay, because for any even function, integral minus a to a is twice integral 0 to a. So twice integral 0 to infinity x power 4, right, into 1 upon root 2 pi e raised to the power minus x square by 2 dx. Okay, now let us put down this value, that is x square by 2 is equal to t, and accordingly we will put down some value of x as well. So this integral is twice integral 0 to infinity. So what is going to be the x square? Okay, what is going to be the x power 4? X square is 2t, so x power 4 will definitely be equal to the 2t ka whole square. Then I have 1 upon root 2 pi e raised to the power minus t, because x square by 2 ko put kar diya. So what is going to be dx, dear? Okay, if you differentiate, you get x dx is equal to dt. If you differentiate on both the sides, so x dx is equal to dt. So what is going to be the dx? It is dt divided by x. Then what is going to be x? Okay, what is going to be x? So यहाँ से x भी लिख लीजिए. X will be root over 2t, root over of 2t. Okay, so let's just substitute all these values here. Okay, so x will be the root over 2t. Okay, so root 2 into root 2 will be 2. This is cancelled with the 2 available above. Okay, root pi is a constant that can be taken outside. 2 ka square 4, 4 taken outside, divided by root pi, integral 0 to infinity. Now you have t square upon root t, so total t raised to the power 3 by 2 I can say. Okay, t square upon root t, so t power 3 by 2 e raised to the power minus t dt, and this is the gamma function now, right? This is the gamma function where n minus 1 is equal to 3 by 2. So what should be n? N is equal to 5 by 2. Okay, integral x power n minus 1 e power minus x dx is equal to the gamma function. So this is nothing but the representation of the gamma function, right? So 4 upon root pi, gamma 5 by 2. But how do you solve gamma 5 by 2? Right? How do you solve gamma 5 by 2? You will be using some important results here. मैं highlight कर देता हूँ. Okay. Gamma n, integral x raised to the power n minus 1 e power minus x dx. That is the gamma function, limit integral 0 to infinity. Gamma n plus 1 is n gamma n, right? Gamma n plus 1 is also equal to factorial n if n is integer. Here it is not integer, but if it is integer, then we can directly use the factorial n, right? Also, one more value to be remembered, gamma of half is given by root pi. Whenever you want to deal the questions with gamma function, these are the basic things that you must remember. Definitely Akbar will plan for electrical as well. Okay, so here to write down the value of gamma 5 by 2, what I am going to do, I am going to break it as 3 by 2 plus 1. Okay, eventually in small steps I will come up to the gamma half. So यहाँ पे ध्यान देंगे आप, right? Gamma n plus 1 is n gamma n. So this will become 3 by 2. Gamma n plus 1 is n gamma n. So 3 by 2, gamma 3 by 2. Okay, now this becomes how much? 4 3 are 12, or actually 6 by root pi. This was root pi. Okay, so 6 by root pi. Gamma 3 by 2. Gamma 3 by 2 को break कर देंगे. Gamma half plus 1. Put it as half plus 1, and gamma n plus 1 is again n gamma n. So half gamma half. So this becomes 3 upon root pi. What is the value of gamma half? That is also root pi. So root pi cancel. Final answer will be 3. The final answer is going to be what? The final answer is going to be 3, everybody. Clear hai? Okay, let's move ahead. So that is the correct answer, option number A. That is the correct answer, option number A. Moving ahead to the next question here. Okay, so consider a transformation, okay, T from R3 to R2, where R3 and R2 we all know. If it is not mentioned also, we should know what is R3 and R2. They represent the 3 and 2 dimensional real column vectors respectively. Also, what is that transformation? That transformation is AX. Okay, that transformation is AX. Okay, for some matrix and each x in R cube. So what is this? It is going to take an input x which is in R cube. Okay, and it is going to return an output which is in R2. Okay, let us write down the output as B. Let us say the output is B. What does it mean? That the input x is in R3, that is a column vector of 3 cross 1, and output is in R2. R2 means it is a real column vector, okay, which will be 2 dimensional, that is 2 cross 1. Okay, on the basis of this, you have to judge how many rows and columns A and what is the maximum possible rank. Okay, what is the maximum possible rank? ठीक है, तो यहाँ पे ध्यान देना है. A m cross n to be multiplied by vector x, which is 3 cross 1, gives you the result B, which is 2 cross 1, and for the multiplication to take place, on the left hand side, n should be equal to 3. Otherwise, the matrices cannot be multiplied, AX cannot be multiplied, so n should be 3. And then the final result, AX, should be of the form number of rows of first into number of columns of second. That should be of the form m cross 1, right? So m का value 2 आ जाएगा, n का value 3 आ जाएगा. So A is a matrix of 2 cross 3. Okay, 2 rows and 3 columns. 2 rows and 3 columns. So what is the maximum possible rank? What is the maximum possible rank? A is a 2 cross 3 matrix. So largest possible minor is of size 2. Can you make a minor of size 3? Not possible, na? Okay, to make a minor of size 3, you should have 3 rows and 3 columns. Okay, so maximum possible minor here will be 2 cross 2. Okay, so rank of A, maximum can be 2. Okay, or it can be less than 2. I'm not telling that it is 2. That depends on the elements of A. So A matrix is not given, but we know its size 2 cross 3. Its rank cannot be greater than 2. Largest order of non-zero minor. Okay, so what is the largest possible minor? It is 2 cross 2. The rank will be 2. Maximum possible rank will be 2. So correct answer is C here. 2 rows, 3 columns, and the rank is equal to 2. And the rank is equal to 2. That's it. Okay, that's it. Okay guys, a fundamental question from signal and system. Let's move ahead. Consider a transformation. Okay, given the data sequence 1, 2, 3, 4, 5, which passes through a linear time invariant system with the impulse response Hence is equal to 5, 4, 3, 2, 1. What is the output of the filter? What is the output of the filter? Very fundamental. Sum by column apply karenge, nothing much. Okay, I'll just apply sum by column method. I'll write down any one of the input here, 1, 2, 3, 4, 5, to be multiplied by, to be convoluted with the another signal, that is 5, 4, 3, 2, 1. Okay, so multiply 5 by all the elements on the top, the 5, then 5 2s are 10, 5 3s are 15, then 20 and 25. Multiply with 4 and write down the result 1 unit right shifted. Okay, so 4 2s are 8, 4 3s are 12, 16, 20. Now multiply by 3, so 3 2s are 6, 3 3s are 9, and 3 4s are 12, 3 5s are 15. Okay, then if I multiply by 2, so 2, 4, 2 3s are 6, 2 4s are 8, and 2 5s are 10. Next is multiplying by 1, so 1, 2, 3, 4, 5. Right. Okay, so just add up. Okay, so 5, 14, this becomes 26, and then I have 32, 40. Correct, this is 41, 50, 55. Option to match ho gaya already. Okay, this is again 40, 26, 14, 5. So what is the correct answer? The correct answer is C. The correct answer is equal to C. Okay, it's a basic convolution game. It is a very basic convolution based question, right everybody? This is a very basic convolution question. Okay, chalo, let's move ahead. Let's move ahead. Okay. For what purpose, Madhu? Whether you're talking with respect to ISRO or GATE, Madhushri? Chalo. Next question, guys. Consider a signal Vt with the Fourier transform Vf. If V dash represents the Fourier transform of V2t, what is the relation of V dash f to Vf? Property based Fourier transform question. Vt has the Fourier transform Vf. So as per the basic Fourier transform property V2t, what should be the Fourier transform? Okay, it should be 1 upon modulus of 2, that is 1 by 2, V of f by 2. Because the property that you will apply is the Fourier transform of xat is given by 1 upon modulus of a x of f by a. 1 upon modulus of a x of f by a. Right. So 1 upon 2 V of f by 2. 1 upon 2 V of f by 2. Okay. And they are telling that V dash f is the Fourier transform of V2t. Right. So I can say that what is the V dash f? I have calculated, that is 1 by 2 V f by 2. A fundamental Fourier transform property question. Magnitude is scaled by 0.5. Yes, this becomes 0.5. Of course. And Vf by 2. Vf by 2 represents what? If you talk about scaling with respect to the frequency domain, the scaling factor is half. That means it will be the expansion. It will be expansion. Okay, whenever the scaling factor less than 1, it is expansion. Whenever it is greater than 1, it is the compression. The correct answer is going to be B. The magnitude is scaled and the bandwidth is expanded. Okay, the correct answer is B. Magnitude scaled by 0.5, bandwidth is expanded. Okay, moving ahead to the next question, dear. A fundamental question again, the unit step response of a system with the transfer function 1 minus s upon 1 plus s is given by which of the following? So I want to calculate unit step response of the system. I want to calculate the unit step response of the system, right? Unit step response of the system has to be calculated. Okay. So fundamentally go for your revision of gate notes and practice the PYQs of ISRO and DRDO. Okay, as well as if you find time, practice the PYQ, revise the PYQs of GATE also. All that will be very helpful in ISRO, Madhu. The unit step response of a system with the transfer function 1 minus s upon 1 plus s is given by which one of the following? Is given by which one of the following? Check kar lete. Okay, so I want the unit step response. Unit step response is the response. Okay, unit step response. Okay, suppose the transfer function is given by ys upon xs. Okay, the ratio of output by input. Unit step response is the response when the input is step, right? When the input is step. So I want to take xt is equal to the ut. So the Laplace transform of unit step signal we all know is 1 by s. So what is going to be the response? What is going to be output? Multiply the input, okay, with the gain. Input into gain will be the output obtained here. Okay, and then I will split this function by the partial fraction a by s plus b by 1 plus s. Okay, and what is there on the left side? 1 minus s upon s 1 plus s. Okay, right. So this can be written as, let's quickly simplify the partial fraction calculation. Right, putting s equal to 0. If I put s equal to 0, I will get the value of a, which is 1. If I put s is equal to minus 1, I will get the value of b, which is 2, and here pe minus 1 aayega, so b is minus 2. B is minus 2, right? So I can clearly say that the output after partial fraction is a is 1 by s, and b is minus 2. So minus 2 upon 1 plus s, yeah, let me write it as s plus 1. So what is its inverse Laplace transform? That is very simple now. So what is this inverse Laplace transform yt? The inverse Laplace transform yt is equal to 1 by s. 1 by s is the Laplace transform of unit step, as you know, right? So this is going to be ut minus 2 upon s plus 1 and 1 upon s plus a e power minus at ut. 1 upon s plus a e power minus at ut. So ut minus 2 e power minus t ut. Okay, or we can take ut common and then the answer is a. 1 minus 2 e power minus t ut. That's it. 1 minus 2 e power minus t ut. That is the option number A. That is what is the option number A. Okay. That is what is the option number A. Moving ahead to the next. Okay, moving ahead to the next. A discrete time linear time invariant system with the input sequence xn and output sequence yn is characterized by yn equal to 0.1 xn plus 0.9 yn minus 1 if two such systems are connected in series. Which of the following is the governing difference equation of the overall system? Okay, which one of the following is the governing difference equation of the overall system? Check karte. Okay, so what is yn? Okay, a difference equation is given 0.1 xn plus 0.9 yn minus 1. Okay, and two such similar systems are connected in cascade. Okay, so when systems are connected in cascade, see, either if you know the impulse response, so you can convolute. The impulse response are convoluted. Number 1. Okay, the impulse response are convoluted. Number 2, if you want to talk in terms of transfer function, when two systems are connected in cascade or in series, the transfer functions are multiplied. Can I get its transfer function quickly? To get the transfer function, I will be taking the Z transform on both the sides. Yes. So if I take the Z transform, let's say yn Z transform is yz is equal to 0.1 xn. What is the Z transform for xn? It is xz plus 0.9 yn minus 1, and as per the Z transform property, yn minus 1 Z transform will be Z inverse into yz. Will be the Z inverse into the yz. Correct? Right. So I take the yz common. Then I am left with 1 minus 0.9 Z inverse on the left side is equal to 0.1 xz. Okay. And we know that the transfer function of any system is the ratio of output to the input Laplace transform. Okay. Let us say this transfer function is gz, that is the ratio of output to the input Z transform, yz upon xz. So that is 0.1 divided by 1 minus 0.9 Z inverse. Okay. Now that is the transfer function of one system. Now two such systems are connected in series. Okay, two such systems are connected in series. Both of them have the transfer function g. Both of them have the transfer function g. So what is the overall transfer function of the cascaded system? It is g into g, right? So overall transfer function is g into g. Okay, so that is g square. So 0.1 upon 1 minus 0.9 Z inverse ka whole square. That is the final transfer function. That is the final transfer function. Okay, now this is going to be, if I simplify, 0.01 divided by 1 a square plus b square, so plus 0.81 Z power minus 2 minus 2ab. Okay, so minus 2ab, so minus 1.8 Z inverse. and this is YZ divided by XZ. Okay. Now you have to take the inverse Z transform. Good morning all. Now you think about inverse Z transform, dear. Okay, so when you think about inverse Z transform, you get 1 into YZ plus 0. Yeah, ऐसा लिखते हैं, sequence में लिखते हैं, minus 1.8 Z inverse YZ plus 0.81 Z power minus 2 YZ is equal to 0.01 XZ. Now take the inverse Z transform. So this is going to be the term Yn minus 1. Z inverse means right shift, 1 unit right shift, Yn minus 1. Z power minus 2 means 2 times right shifted, so Yn minus 2 is equal to 0.01 Xn. Let us see the option then. Let us see the option. Yeah, so definitely the direct answer that has matched here is option number A. Yn minus 1.8 Yn minus 1 plus 0.81 Yn minus 2 is 0.01 Xn. That's it. The very correct answer is option number A. The very correct answer is option number A. Okay, dear. The very correct answer is option number A. Moving ahead to the next question. Which of the following is an example of oversampling ADC architecture? It's a factual question. Okay, we'll not discuss all the 4 here, otherwise it will take a lot of time. Oversampling. Okay, sampling at a rate much greater than that of the Nyquist rate, and that is there in the sigma delta. Okay. Sure, Ghosh. We'll bring up previous year EE paper also. Don't worry. Okay. So, oversampling ADC architecture. Oversampling is in the case of sigma delta ADC. Okay. So, this is almost a fundamental factual question. If you have studied ADC, you must be knowing it. Okay. Which of the following statements is wrong? It's a fundamental number system question, but only thing is they have made the question little bit time consuming because you have to check option by option. Okay. You have to check option by option. Okay. So, here just let me tell you the hint. Okay. The correct answer here is going to be C. Why? Okay. Why? Dekho. The option number A and D are very simple to solve because conversion from binary base 2 to base 8, base 2 to base 4, base 2 to any 2 power n base, it's very simple, it's very direct. Okay. But yahan pe if I solve C and tell you why it is wrong, okay. So 2206 and that is a 2202, it is a number in base 6. It is a number in base 6. So convert in decimal. Okay, so that is 2 into 6 cube. These are the positions, na? 0, 1, 2, 3. So 2 into 6 cube, 2 into 6 square plus 0 plus 2 into 6 power 0, right? So let's calculate how much is this going to be. This is 2 into 216 plus 2 into 36 plus 2. Okay, so ye ho gaya 432 plus 72 directly. So this is 506, I think. This is total 506. Okay. Now, on the right hand side, I have 426, a number to the base 11. So, this is going to be 4 into 11 square. This is position 0, 1, 2. Okay. Plus 2 into 11 raised to the power 1 plus 6 into 11 raised to the power 0. Right. 11 square 121. Okay. So, 4 into 121 plus 2 into 11 plus 6. So, this is how much? Whether it's going to be 506, dekh lete hain. This is 4 and 84 plus 22 plus 6. No. Okay, this is 490, so this is 512. This is 512. Okay. This is 512. The correct answer is C. Okay. ठीक है. Okay, Akbar, I'll give you the hint. How many binary bits are required to represent a 9-digit decimal equivalent? Okay, that 9-digit decimal number can be anything. It can be small, it can be big. Okay, if nothing is mentioned, what will you assume? You will assume the worst case. Okay, worst case. Highest 9-digit decimal number, Akbar, 10 power 9 minus 1. Highest n-bit binary number, 2 raised to the power n minus 1. The highest n-bit binary number is given by 2 power n minus 1. The highest 9-digit decimal number is 10 power n minus 1. Okay, so binary bits must be so much sufficient that it is able to accommodate this highest digit number. Okay, so this should be greater. So you have to just solve 2 power n greater than 10 power 9 and then take the log and solve it up. Okay, Akbar, this is the hint to solve it up. This is the hint to solve this. Okay? Any more doubts you can ask me. Which of the following statements is correct, dear? Which of the following statement is correct about the associative and commutative or NAND and NOR? Are they commutative? That is clearly known to us, na? Okay, dear, A into B whole bar, that is NAND gate. Yes. Is it BA whole bar? Yes, because AB is commutative, the AB can be replaced by BA. Similarly, for NOR as well, A plus B is B plus A. Addition is commutative. So, A plus B whole bar is B plus A whole bar. So, they are both commutative. Associative होते हैं क्या? Whether they are associative. Let's prove that. Bhai, what is associative? What is an associative operator? Like multiplication is associative. Dear, multiplication is associative. अगर मैं multiplication की बात करूं, in simple, if I talk about multiplication, right, and you want to multiply three numbers ABC, right? So, ABC can be written as A into BC. Any two can be multiplied first, or it can be written as AB into C, or it can be written as A C into B. चलो वो तो छोड़ दीजिए, वो तो commutative के साथ mix हो जाएगा. But at least you are able to deal with this, right? Multiplication we know is commutative because whether you multiply BC first or then with A or AB then with C, okay, AB then with C, okay, the results are equal. Similarly for addition as well. Okay, so addition, multiplication, they are definitely associative. Okay, associative. But what about NAND and NOR? Check कर लेते हैं sir. Okay, if you know the properties, you must be able to write the answer directly. Otherwise, I will tell you. So, A into B whole bar. Okay, देखो, what is the associative? कि पहले take the NAND of AB and then take the whole NAND with C. Okay, then take the whole NAND with C. What is this answer equal to? What is this answer equal to? When you apply the De Morgan's, it will become AB plus C bar. Right. On the other side, first I will take the NAND of BC. Okay, first I will take the NAND of BC and then whole NAND with A. And then whole NAND with A. And again, if I apply De Morgan, this is going to be A bar plus BC. Are these two equal? Are these two equal? Not at all, no sir. These two are not equal. These two are not equal, sir. Okay. So, A, B bar into C whole bar, and one side I have A, BC bar and then whole bar. They are not equal to each other. So, and not only for NOR, not only for NAND, similarly you can prove for NOR as well that these two are commutative but not associative. The correct answer is D. Fundamentally, you can note down as a property as well. Okay, not only for NAND and NOR, but for NAND, NOR, XOR, XNOR, or the basic gates also, you must remember which of them are commutative or associative or etc. ठीक है जी. चलो, let's move ahead. Let's move ahead to the next. Which of the following digital devices requires an external refresh memory? Okay, it's definitely DRAM, dynamic RAM, because dynamic RAM is the RAM which is built using capacitors. Okay, and then you need to refresh it externally. Okay, periodically and externally. Why? Because capacitors have the tendency that they will be, automatically discharged in certain period of time. Okay, so correct answer is DRAM. These are fundamental questions. ठीक है, इस पे तो ज़्यादा दिमाग लगाने का नहीं है. If you know these structures, you are able to answer. Otherwise, you don't. Okay. Next, what would be the maximum operating frequency of a mod 8 counter constructed with JK flip-flops having propagation delay of 8 nanoseconds? Having the propagation delay of 8 nanoseconds. Okay, so JK flip-flops, the flip-flop propagation delay is 8 nanosecond and it is modulus of 8. It is mod 8. So how many flip-flops will be required? They have given the modulus of the counter. They have given the modulus of the counter. So how many flip-flops would be required? How many flip-flops will be required? Okay, we can take n equal to 3 flip-flops. For 8 bits, for 8 states, ideally 3 flip-flops are sufficient. So we can take the n is equal to 3. N is equal to 3 means number of flip-flops. Yeah, number of bits, every bit is 1 flip-flop. Okay. Now, also, okay, also they are not mentioned whether they have taken a synchronous or a ripple design. They have taken a synchronous or ripple. कुछ भी नहीं mentioned है. चलो, even if I tell you the answer with respect to both, okay, with respect to both, if I take a synchronous design, say for example, if I take a synchronous design, okay, what is the propagation delay? Okay, the propagation delay, the worst case propagation delay, yeah, let me write down the clock frequency formula only directly. The maximum clock frequency formula for synchronous counter is 1 upon T flip-flop. Okay, because the total delay of synchronous is approximately equal to the delay of 1 flip-flop. Okay, ठीक है. तो एक तो इससे निकाल लेंगे, that is 1 upon 8 into 10 raised to the power minus 9 megahertz में लिखना है. तो 1000 10 power 6000 by 8 125 megahertz. Okay, if I take a ripple design, सर देखो डिजाइन तो बोला नहीं है. Let me try both first of all. Okay, and f clock maximum here will be 1 upon nt flip-flop, because the delay in ripple flip-flop, the total delay in the ripple flip-flop is the delay of one flip-flop into n, because the clock propagates, okay, the clock signal propagates from MSB to the LSB one by one. Okay, so the delay of every flip-flop is correspondingly added. Okay, sequentially it is added. So this is going to be 1 upon, what is n? N liya hai 3 into 8 nanoseconds. That means previous answer divide by 3 directly you can say. So when you divide this by 3, you will get 41.67 megahertz. You will get 41.67 megahertz. 41.67 megahertz. None of the answer is correct. Now, actually, ये इसका actual analysis है. ये इसका actual analysis है. The question or the option, something is wrong here. Okay, something is wrong here. अब देखो, answer given by ISRO was B. That is 100% wrong. Okay, but I'll tell you what was the logic. What is the mistake they have done in the question? What is the mistake they have done in the question? ठीक है. None of the answer is actually matching if I take the flip-flop delay as 8 nanosecond. अब आप यहाँ पे ध्यान देना. Actually, they might have thought, they might have written mod 8 by mistake. Okay, they might be considering a 8-stage flip-flop. Okay, they might be considering a 8-stage flip-flop. 8-stage flip-flop, right? Okay, so if I consider n is equal to 8, okay, and considering ripple design, okay, then the clock frequency will become 1 upon NTFF, that is 1 upon 8 into 8 10 raised to the power minus 9. Okay, and then this will become the previous answer. 125 is divided by 8. 125 divided by 8. Okay, 15.625. Here you are going to get the 15.625 megahertz. 15.625 megahertz. Okay. Okay. Yeah, that is why हम आंसर ला सकते हैं भी, but that is conceptually not correct question. We can make the answer somehow come as V, okay, but actually for a modded counter we don't need 8 flip-flops. Na? Yeah, for a modded ring counter we need 8 flip-flops. Okay, so maybe they should specify that we are looking for a ring counter. Maybe they should specify we are looking for a ring counter. For a modded ring counter we need 8 flip-flops. Okay, okay. N is equal to 8 is only possible. Okay, n is equal to 8 is nahi, but then ring bhi nahi hoga na. Ring will then go synchronous manner only. Okay, so somehow this is conceptually wrong. Okay, then ring will go sequentially only, na? Then 1 upon TFF only ho jayega. Okay, so no. Okay, so option B laya ja sakta hai. Okay, option B laya ja sakta hai, but it's just about ki I have an option and I want to unnecessarily bring it. Okay, chalo, moving ahead to the next question. The following state diagram, this is a good question. The following state diagram represents which of the input equation? Okay, given dA is equal to AXY, where dA denotes a D flip-flop with the output. Okay, the X and Y are the inputs to the circuit. That means in the state diagram, the two bits that you are able to see like 0, 0 or 0, 1, these are the XY values. Let me first convert the state diagram, okay, into the state table, and then let's start solving it. Okay, let's start solving it. Okay, no dark current, we can't say that for surety whether they will give it or not. Okay, chalo. So let's make the truth table, and let's say A is the state, X and Y are the inputs, and let's say the next state is A plus. And we know that for a D flip-flop, Q plus is equal to D, right? So Q plus should be D. Okay, so whatever is dA, okay, right? But let the state transition table, and then I will make the excitation signal. What should be the dA to make the state transition occur? So D should be such that whatever next state you want to, dA should be just equal to the A plus. Okay. Now for these 3 bits, let us write down all the informations. Okay. That is 0, 0, 0, 0, 0, 1, 0, 1, 0, all the 8 combinations, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Okay. Now, whenever XY is 0, 0, whenever the input XY is 0, 0, there is no change in the state. Okay, if you are at 0, you will remain at 0. If you are at 1, you will remain at 1. So 0 remains 0, 1 remains to be 1. Okay. Next, if XY is 0, 1, isko dekhenge. If XY is 0, 1, right? So 0, 1, you go to the 1 state. If you are in 1, you remain in 1 state. So anyways, if the input is 0, 1, you have a next state should be 1. Your next state should be 1. Similarly, if the input is 1, 0, ek karke dekhenge. If the input is 1, 0, okay. So from 0 you go to 1, or from 1 you go to 0. So if the input bits are 1, 0, you will change the state. You will toggle. Okay. If it was 0, you will go to 1. If it was 1, you will go to the 0. Okay. Next, last but not the least, if the input bits are 1, 1. Okay, so 1, 1. If you are 0, you will go to 1. If you are in 1, you will remain at 1. That means at any cost, you will be in 1. So if the input bits are 1, 1, the next state will be 1. The next state will be 1. The next state will be 1. Okay. Now, what is dA? As I told you, dA just should be equal to the A plus desired. Should be equal to A plus desired. And now we can just fundamentally solve this problem from the K map, or you can match the options also by one or two particular combination, but we can solve it up completely. Okay, the current state A and the input bits X, Y. This is what A, this is where X is high, these are the columns where Y is high, and output is 0, 111, 1101. Right, 0, 111, 1101. Okay, so if I start pairing it, definitely there is a quad coming up. This can be made as a pair, and these two can also be made as a pair. This quad is completely in Y. This pair is above A and inside Y, A bar X, and this is in A but outside X, A X bar. So what is my dA? What should be my dA? It is definitely equal to Y plus the A bar X plus A X bar. So that is Y plus A XOR X. Y plus A XOR with the X. Y plus A XOR with X. It should be Y plus A XOR with X. The correct answer for the question is C. The very correct answer for the question is equal to the C, dear. Okay. Chalo, moving ahead to the next. The correct answer is C. Moving ahead to the next. Which of the following logic circuit do not have no change condition? Okay, do not have no change condition. We must know it is only D flip-flop, because the next state of the D flip-flop will just follow the command of the input. It is a data delay input, delay latch or a data latch, we can say. Okay, Q plus will just follow what is the input D. Okay, there is no hold state condition here. Right, T flip-flop mein hota hai. Right, whenever T is equal to 0, Q plus will be Q. Okay, in the JK flip-flop, whenever both J and K are 0, Q plus will be Q, remains in the same state. Similarly, in the SR latch also, whenever S and R bits are both 0, then the Q plus is equal to Q, same state condition. No change condition or hold condition. It is not there in the D flip-flop because it will directly be equal to D. Q plus is not Q, it is just equal to the input D. Okay. So, correct answer is A. It is again a factual information question. That's it. That's what I can say. Okay, moving ahead to the next. Yeah. Now VHDL. See, if you have studied VHDL in your bachelor's degree, maybe slightly. Okay. I'm not telling you surely, but you know, maybe they can ask one question from VHDL. Okay. If you have studied this in your bachelor's, okay, not to worry. बहुत basic question आएगा. If you have not studied, okay, don't worry. Okay, just for one question, you can't study a code. You can't study a complete coding language. Okay. So you can ignore it. But if you be logical in reading it, you will be able to understand the question. Okay, let us see. You know, assume that you don't know anything about VHDL. Okay, you don't know about this hardware language. Following statement is written in a process and clock frequency is 24 megahertz. Okay, can you solve it by your logic, even though if you don't know VHDL? Okay, if clock event and clock equal to 1, देखिए कभी C तो पढ़ा होगा, you'll be able to resemble it. It's not like C, but you'll be little bit resemble it. ठीक है, if there are two conditions given, कि if there is a clock event. Okay, now clock में क्या होगा? Clock is like keeps changing from 0, 1, 0, 1, 0, 1, 0, 1. So if there is an event on the clock, event means transition and clock equal to 1. So what transition they want to refer? कि एक तो clock में event हो and then clock becomes 1. So it's a positive edge triggered. They want to specify positive edge triggered. Then what should happen? There is a counter of 4 bit. Okay, that should be counter 4 bit plus 1. Its value should increment. Okay. Its value should increment. So what is this? Whenever positive edge of the clock comes, the value of the counter will increment, otherwise it will not increment. So what they have done is a design of counter. It is the VHDL, very simple VHDL code for a counter. Okay. right? Whenever this event happens, okay, keep doing this. End if, end this particular if block. End if. If means this particular block. Okay. Is that okay, everybody? So, you know how to create the loops, how to create the counter, nahi janna hai. By logic, you should be able to solve the question that this is a 4-bit counter. Now, frequency of the counter 4-bit 2. Because it is a 4-bit counter, okay, let's say it is Q3, Q2, Q1, Q0. Okay, bit number 2. Okay, normally we name the LSB as 0, na? Okay, so 0, 1, 2, 0, 1, 2, 3. Okay, so they want the frequency of this particular bit. The bit 2. Iska frequency kya hoga? If they were asking the frequency of MSB, then to you know, na? Then to you know. Frequency of the bit 2. No, the only mistake that you have done, Akbar and Chinmoy, that bit 2 and the counting starts from 0. That is how you represent the Q0, Q1, Q2, Q3. Q0, Q1, Q2, Q3. Okay. So, Q2 ki baat chal rahi hai yahan pe. Okay. So, what is the frequency of Q2? What is the frequency of Q2? It is given by clock frequency. Overall, it is the Q2, but overall, it is the third bit. Overall, it is the third bit. Okay. So, the clock frequency is divided by 2 power 3. Overall, it is the third bit from the LSB. If you count, the clock frequency is divided by 2 raised to the power 3. Okay. अब ये तो आपको पता होना चाहिए. This is what you study with counters also. What is the frequency at the end of every particular flip-flop? Okay. So clock frequency 24 megahertz given hai. Divide by 8. Answer is 3 megahertz. Answer is 3 megahertz. When will you get 12, Chinmoy or Akbar? You will get 12 when they are asking the frequency of the LSB only, na? That is divided by 2. Okay, that is divided by 2. Let me write down these remembers. Okay, FQ3. Q3 means MSB, and we know that MSB wala rule to sabhi ko yaad hoga. The clock frequency divided by mod number. Okay, what is the mod number for a 4-stage counter, for a 4 flip-flop counter? That is 2 power 4, right? Then similarly, I wrote down FQ2. That is the clock frequency divided by 2 power 3. If they ask FQ1, clock frequency divided by 2 power 2, because Q1 from the LSB you have to count. What is that flip-flop from the LSB? What is that number of the flip-flop from LSB? FQ0, that is the first flip-flop only. So divide by 2 power 1. Okay. Okay, so 12 wala answer kahan pe hoga? That is at the LSB only. That is at the LSB only. Got this, everybody? So even if you don't know the VHDL, but you are able to crack this question. Okay, crack this question. Because you know the fundamental knowledge of the counters, what is the clock frequency, what is the frequency division concept and all. Okay, Akbar, okay. ठीक है, चलो. So for electrical, definitely VHDL will not be expected, but the digital, fundamental digital will be expected. Digital जरूर आपके लिए expected होगा. Okay, and SRAM has the address lines. Okay, this is a memory-based question. Whether it is SRAM or anything, there is a memory-based question which has the memory has address lines which is A0 to A19. That is 20 address lines. Okay, and the data width from D0 to D8. Okay, so there is a 20 address lines, a memory chip with 20 address lines and having D0 to D15. Sorry, so that is 16 data lines. Okay, one line will carry 1 bit. So how many addresses are possible? How many addresses are possible? Okay, capacity की बात चल रही है यहाँ पे. How many total bits can be stored? Okay, in bits or bytes, किसी में भी पूछ सकते हैं. तो total capacity of the memory, right, is equal to how much? Number of addresses, number of locations where you store the data multiplied by how many bits per address you can store. How many bits per address you can store. So how many addresses you have? 2 power 20. Because it's a binary calculation. 20 are the address lines. So using 20 bits, how many addresses you can form? You can form 2 power 20 address. Okay. Multiplied by bits per address. So every address, the data can be stored in 16-bit format. So this is total 16 bits. Options are in bytes. Okay. So this becomes 2 power 20. Acha, what is 2 power 20? 2 power 20 is 1 mega. Into 2 into 8 bits. Remember guys, 2 raised to the power 10, which is 1024. 2 power 10 is 1024, and that is the nearest power of 2, which is closest to 1000. Actual 1000 you can't get, so we write this as 1k. This is in the binary world, this is 1k. 1024 is 1k, not exactly 1000. Okay. Similarly, when you take 2 power 20, it is the 2 power 10 whole square, and what is 1k square? Right, what is the 1K into 1K? You will go to 10 power 6 range, na? That is 1 mega. That is 1 mega. Similarly, 2 power 30. Similarly, 2 power 30 bole. So you will go to 1 giga range. Clear? You will go to 1 giga range. So ye ho gaya. Okay, how much? 8 bits is 1 byte. 2 MB. 2 megabytes is the answer. And none of the option will match. Yes. Correct answer is 100% 2 MB. Okay, so this is the second question that we have seen till now in which options are not matching. In that earlier question, okay, counter based answer somehow aa jayega, but that is not actually conceptually correct. Okay, so there also I have written none of them matching. If I go back, which question it was? Ye wala. Okay, somehow we can make the answer B come, but that doesn't have any proper logic. So none is the actual option matching, and this is the second one. Okay, with no option matching. Moving to the next, guys. Which of the following, it's a logic family fundamental factual question. Which of the following digital integrated circuit cannot be used as wired and it is not possible with the totem pole TTL gate? Okay. Right, guys. So, next question here. The logic function implemented by the circuit can be represented as what? Ekdam logic function, logic se answer batao. Okay. Just tell the answer very, very quickly. Okay, tell the answer very quickly. Okay, it's a NMOS. Okay, it has been implemented using NMOS. Right. We know that these two NMOS are in series. They will create the function AB. Okay, if you have the habit of solving this NMOS logic family question, you must be knowing that these are in parallel. They will create the OR gate. Okay, actually NOR gate. Okay, but later on overall complement kar denge. Right. Right. What is this? If you only take this particular part, alag se show karta hu main. If you only take this particular part, and let me also invite Ashu sir. Sir, my last question, 2 minutes. बस मैं 2 मिनट में writing sir. ठीक है. Okay. Hanji dear. Okay. So let's discuss this. So what I was trying to tell you is कि if you remember, okay, एक छोटा सा fundamental by the time Ashu sir comes up with us. What happened? Some problem. Chodo. Okay. Yeah. So this is based on NMOS, no? Correct. This is the NMOS inverter. This is going to be the inverter. Let's say this is the Boolean function f, that is going to be a bar. That is going to be a bar, right? Because whenever a is equal to 1, the switch will be closed. Okay. Similarly, some particular connections are given here. Usko bhi hum dekhenge. Okay. But whenever a is equal to 0, the switch is closed. Okay, this NMOS switch will be closed and it is connected to the ground. The output will be 0. But if the a is equal to 0, this is open, right? And if this is open, okay, you get a connection from here, okay, which is open. And because the connection is open, there is no current flow in this resistor. This is just to use this here, the resistor of this device will be used, okay. And since there is no current flow, whatever is the voltage here, same will apply here. Here it is VDD, logic 1. So output will be 1. So if A is 0, output is 1. If A is equal to 1, output is 0. So what is this? This is nothing but your inverter. Okay. Similarly, guys, a quick recollection. This is your AND gate. Why? Because whenever both the inputs are 1, 1, देखो, whenever both the inputs are 1, 1, AND नहीं होगा, NAND होगा actually, I'm sorry again, right? Whenever both the inputs are 1, 1, okay, 1, 1, okay, then the circuit is complete. मतलब both the switches are closed, okay, and the output is connected to the ground. Okay, there will definitely current flow and there will be a voltage drop. This will become 0 because it is connected to ground. So when both the inputs are 1, 1, then only the output is 0. But if any of the switch is open, that means if any of the input is 0, if any of the switch is open, the path is disconnected, okay, and there is no current flow. So whatever is the logic 1 will appear and output will be high. So whenever any input 0, output is high. Okay, NAND gate. This is what NAND gate is. AB whole bar, right? Similarly, Okay. Here what is the condition? That if any of the switch is closed, if even a single switch is closed, that is even a single output is equal to 1, output is connected to ground. This is the output. Output is connected to ground, output will be 0. So if any input high, output is low. But if both the inputs are 0, only when both the inputs are 0, okay, this particular connection is not completed. I mean, both the switches are open and VDD will, that no current flow in the above path, and VDD will be F. That means F will be high. So when both the inputs are 0, output is high. If any input 1, output is 0. That is a NOR gate. That is what is NOR gate. Okay. That is what is NOR gate. Okay. So what is the idea that you can directly look into and allot? Okay. This particular portion. Okay. It is going to be A into B whole bar NAND, but let's start with AB. We know that output at this particular line will be AB whole bar. Okay, will be AB whole bar. Okay, but वो bar बाद में करेंगे. First, I will be getting a AB. Okay, then this is connected in parallel. Okay, so what is this? This is in the input A only, right? यहाँ पे A आ गया. तो A plus C. A plus C. This A plus C is also parallel with this structure. तो यहाँ पे apply किया plus. Okay. Then there is one more parallel connection. What is coming here? It is again A coming up here, and this is the input B. So what about these two? These two are in parallel, so B plus D. These two are in parallel, that is B plus D. Connected in series with A, so multiplied by A. And this whole structure again in parallel with the previous, right? It is something like this. It is something like this. And now take the whole bar. As I told you, the whole bar will be the output. So now this is AB plus A plus C, right? Plus AB plus AD, if you open this bracket. So what is AB plus AB? What is X plus X? It is X. It is X, right? So it will be just AB plus A plus C plus AD whole bar. Correct answer is D. Okay. This AB plus AB will be equal to 1AB. Okay. Okay, guys. So what we have discussed till now is the questions from maths, signal and systems. Okay, 2 questions from maths, 4 questions from signal and system. Okay, and then there were 11 questions from digital. I've told in one of my earlier video also that digital and EMT, they carry the maximum number of questions, almost more than 10 every time. Okay, but also at the same time, whatever exam may be, network control, EDC, analog, they also play the very crucial look. Okay, so now network control. Okay, Ashu sir is ready, I think. So let me just again make a call, and he is ready to bring up the questions of network control and power electronics as well. Sir, मैं stop कर दूं?
हाँ सर, कर दीजिए.
So just a minute.
Hello everyone. Thank you Rakesh sir, and hello guys. I hope you all are fine there. So tell me my audio and video. Tell me about my audio and video, whether it is clear or not. Everyone. Everyone, please tell me about my audio and video. I think it's fine. Tell me guys. Good morning everyone, good morning, and I hope your preparation is going well. So you have completed some subjects like digital and other subjects like maths, digital, okay, with Rakesh sir. So now it's my turn, and I will start with the network and control system, okay, and power electronics. Power electronics in EC is not that much weightage. Only 1 or 2 questions will be there, and the maximum questions are from network theory and control system. Okay, so let's start the session guys. Let's not delay. This is your first question on your screen. So you can see that for a given circuit, switch remains closed for a long time. So this is the switch, okay, it remains closed for a long time and opens at t equal to 0. At t equal to 0, you are opening it, okay. Assuming ideal model of every device, find the steady state magnitude of the voltage across the capacitor. So across the capacitor, we need to find the steady state voltage. Now how to simplify this, how to solve this problem? Look, this is MOSFET, and in MOSFET, you can see that this gate terminal and the drain terminal, okay, the gate terminal and drain terminal are sorted. Whenever you have such type of MOSFET in which the drain terminal and gate terminal is drain terminal and gate terminal is sorted, that MOSFET is kind of, you can say it's a short circuit, okay, it's in saturation and it will provide the short path. You can assume it ideal. Okay, if you are assuming it ideal, it means it will provide you the short path. So don't worry about this device. It will provide you a short path, nothing else. So if it is a short path, then the question is very simple. Okay, then the question is very simple. The switch was closed for a long time. If the switch was closed for a long time, the inductor will behave like short circuit, because we know that switch is closed for a long time and this circuit is behaving, this circuit is under steady state. Under steady state, inductor will behave like short circuit. This is also short circuit, this is also short circuit. Now if it is short circuit, the current will follow this path only. Okay, current will follow this path only. It means the current in the inductor is 10 ampere. Current in the inductor is 10 ampere. Now if you are opening it, then you can see that there is one inductor and one capacitor in parallel, because you are opening it. So this inductor has some initial current as 10 ampere and you have one capacitor and they are connected in parallel. So now the circuit is very simple. Okay, so now you can solve for this circuit. So how can you solve that? Tell me, guys. So we have an inductor and it has some initial current I0 as 10 ampere, and we have a capacitor, and we need to calculate this steady state voltage, this voltage VCT. Okay, we need to find the magnitude of steady state voltage across the capacitor. So it's very simple now. How to solve it? Tell me, guys. What you can do is, to calculate this voltage, you can apply Laplace transform. Or if you remember what is the voltage across the capacitor in LC circuit, then it will be very better for you, very fine for you, but you can tell which option is correct. But let me apply Laplace transform, because many students are not aware of the direct answer for this question. So if you are not aware of that, what you can do is, you can apply the Laplace transform. Okay, L is half millihenry. Okay, and this is Li0. So Li0 is 5 milliampere. L is 0.5, half, I0 is 10. So if I multiply, I will get 5 milliampere. And on this side, you have 1 by CS. Okay, 1 by CS. So C is 20 microfarad. Okay, anyway, I'll put the value of C. So first you calculate this current IS. Okay, you calculate this current IS. IS will be 5 into 10 to the power minus 3 divided by LS. This is LS. Okay, 1 by 2 into S. So LS 1 by 2 into S into 10 to the power minus 3, LS plus 1 by CS. So this is my current. This is my current in this circuit. Now this current multiply by 1 by CS. Is the voltage VCS. Okay. Now if you simplify this, you will get 5 into 10 to the power minus 3 divided by 1 by 2 into CS square into 10 to the power minus 3 plus 1. You will get this. I am taking this as LCM. If you are taking this as LCM, this will go in the numerator and it will cancel with CS. Okay. So this is the expression, guys. This is the expression. Now you can take this half into C into 10 to the power minus 3 common. If you are taking this common, this 10 to the power minus 3 will be gone. So 5 divided by C by 2. I am taking this as common, and here you will left with S square plus 10 to the power 3 upon C. Okay, you are left with this. So I am taking this as common. So this part is there. Now you can simplify this. This will become 50 upon C. Okay, this will become 10 upon C. Excuse me, 10 upon C 1 over S square plus 10 to the power 3 upon C. C is 20 microfarad. So 10 to the power 3 divided by 20 into 10 to the power minus 6. Okay. So you can simplify with this. Now you will see that this 20 will go in the numerator, or you can simplify this 1000 upon 20 into 10 to the power minus 6. This 10 to the power minus 6 will come in the numerator. So it will become like this. 10 by C. C is 20 into 10 to the power 6 divide by, here you will get S square plus this will become 10 to the power 9 upon 20. Fine. and you have to take the Laplace inverse of this. You have to take the Laplace inverse, and you have to calculate the steady state value of this. Okay, steady state value of this. I hope it is clear. So now you can see that it is 10 and C value is 20 micro. So here in the numerator it is cancelled, and in the numerator you will get 5 into 10 is to the power 5 into 10 is to power 6 divide by S square plus 5 into 10 is to power, tell me guys, 5 into 10 is to power 7, I suppose. Okay, you will get this. Okay, now what you can do is you can take the Laplace inverse of this function and you can check what is the amplitude of the sine wave. What is the amplitude of the sine wave? Okay, this is the way. Only thing is you need to check my calculation. The only thing is you need to check my calculation. Okay, and this way you can get the capacitor voltage easily. Okay, let me repeat this again. When you are opening this switch, whatever the inductor current it has stored, that current will flow through the capacitor, and because of that it will build up some voltage, and that voltage under steady state is asked. Okay, so what I did is, we know that the initial current in the inductor is 10 ampere, so I can replace this inductor with LS, half S millihenry. So that milli is this milli, because of this milli you will get 10 to the power minus 3 here. Okay, 10 to the power minus 3. So this is LS and this is Li0. L is this, I0 is 10. So you will get 5 into 10 to the power minus 3, 5 milliampere, and 1 by CS. Capacitor will become 1 by CS. So now you can see that the current will be 5 into 10 to the power minus 3, 5 into 10 to the power minus 3 divided by this LS plus 1 by CS. Okay, and now you can simplify this. Okay, this is the current, multiply by 1 by CS is this voltage. So you get this voltage. Okay, now let's simplify this. CS will go in the numerator. Okay, and it will cancel, and in the denominator you will have 1 by 2 CS square into 10 to the power minus 3 plus 1 here. Okay, now you can take this common, 1 by 2C. Okay, if you take 1 by 2C common, then here you 1 by 2C into 10 to the power minus 3, you are taking this common, so 10 to the power minus 3 will go on here. Now in the numerator you left with 5, and here you have C by 2 S square plus, here you will get 10 to the power 3 upon, I think you will get 2 more, 2. Okay, this is 2 into 10 to the power 3. Okay, because you are taking half C into 10 to the power minus 3 common. Okay, so you're left with this. Now it will become 10 by C 1 over S square 2 into 10 to the power 3, 2 into 10 to the power 3 divided by C. Okay, now you can see that this value came out to be, you can cancel with this 10. Okay, so this will become 10 to the power minus 5 and 10 to the power 3, so it will become 10 to the power 8. So in the denominator you will left with 10 to the power 8. Okay, so what you can do is, here let me simplify this. So the calculation part should be correct. Okay, now what you can do is 10 by C into 1 divided by S square plus, tell me guys, this is 10 to the power 8. Fine. Now you put the value of C, then the value of C is 20 microfarad. Okay, so you will get 1 by 2 into 10 to the power 6. If I put C as 20 into 10 to the power minus 6, you are left with this into 1 over S square plus 10 to the power 8. Now I have to take the Laplace inverse. Laplace inverse is very easy. You know that this 10 to the power 8 is the square of 10 to the power 4. Okay, so what I can do is I can write it like this. 50 into 10 to the power 4 divided by S square plus 10 to the power 4 square. Okay, and it will become sine. It will become sine, and the amplitude is 50. Okay, so answer is Calcutta. It's very simple. Okay, this question was very simple and you can easily solve this. Only thing is the Laplace transform. Let's come to the next question, guys. The next question is again very simple. A 18 microfarad capacitor holding a charge Q coulomb is connected to the circuit at t equal to 0. At t equal to 0, a capacitor is connected here, and at t equal to 0 it is holding a Q charge. It is holding Q charge. At the time at which the capacitor will be discharged to approximately Q upon, now this factor is very important, Q upon 2.72. that is Q into e to the power minus 1. E to the power minus 1 has this value because this is E, this is E. So Q upon E. So I can write it Q into e to the power minus 1. Okay. Now we need to tell the time by which this capacitor is discharged to this value. Now how to calculate that? We know that the initial charge, because of that initial charge, you will get the initial voltage. Okay. V0 is equal to Q by C. This is the initial voltage we have for the capacitor. And the voltage is decreased to, because this charge has decreased. So this voltage has decreased to Q into e to the power minus 1 by C, because this is the new charge. Okay, so it will become V0 into e to the power minus 1. It means this voltage, initially it was V0, now it is decreased to V0 into e to the power minus 1. How much time it will take to decrease? For this circuit, we know that there is only one capacitor and all the things are resistor. Okay, so if there is some initial voltage across the capacitor, then the VCT expression will be equal to VC0 e to the power minus t by tau. This is the expression for this capacitor voltage. So the capacitor voltage is decreasing exponentially. How much time it will take to reach to this value? Obviously, this t has to be equal to tau. In one time constant, this will become to this value. Now, what is the time constant for this circuit? The time constant for this circuit is RC, RTH into C. Okay. So we need to calculate the Thevenin resistance multiply by the capacitance. Now, how to calculate the Thevenin resistance? C is already known to us, 18 microfarad. So we need to calculate RTH. To calculate RTH, we need to remove this capacitor and we need to calculate equivalent resistance between these 2 points. Okay, we need to calculate equivalent resistance between 2 points. So let's see, let's call this point as A and let's call this point as B. So we need to find the equivalent resistance between A and B. So let's simplify the diagram. From A, you can see that there are 2 paths. One path is going to C, one path is going to D. Okay, 2 kilo ohm and 4 kilo ohm. Okay, 2 kilo ohm and 4 kilo ohm. One is going to C, one is going to D. Okay. Now from C to B and D to B. From C to B you have 3 kilo ohm. C to B you have 3 kilo ohm. And from D to B you have 12 kilo ohm. Fine. From D to B you have 12 kilo ohm. And there is one more resistance in between. From C to D you have 6 kilo ohm. So this is the circuit. This is the circuit between A and B now. We need to calculate equivalent resistance for this circuit. How to calculate equivalent resistance for this circuit? Obviously, this is not a balanced bridge. This upon this is not equal to this upon this. So you have to convert delta into star. So what we can do is we can convert this 3, 12, 6 into star. Okay, this side or this side. So I am preferring this side because it's divisible by 3. All the elements are divisible by 3. That's why I am preferring this side. Okay. So now the circuit will look like this. This is 2 kilo ohm. This is 2 kilo ohm. This is 4 kilo ohm. Okay. And I'm making it star. Okay. I'm making it star. Now, can you tell me what is this value? This is 3 into 6 divided by 21. Total sum. Total sum is 21. 3 into 6 by 21. So it will become 6 by 7. 3 into 6 by 21. Okay. 3 into 6 by 21 is 6 by 7. Now, what about this resistance? This resistance is 3 into 12 by 21. So it will be 12 by 7. What about this? 6 into 12 by 21. So it will become 24 by 7. 24 by 7. I hope it is clear. Once you get this circuit, now you have to calculate equivalent resistance. Whatever the equivalent resistance, multiply by this C. Okay. Now, what is that equivalent resistance you have to calculate? Okay. Let me tell you what is that equivalent resistance. The equivalent resistance will be 34 by 9, I suppose. Okay. 34 by 9. Please check it. Okay. This is 34 by 9 RTH. I have already calculated this. So 34 by 9 kilo ohm. Okay. This is my RTH. multiply by C. C is 18 microfarad. Since it is kilo ohm, it is microfarad, so you will have one more 10 raised to power 3. Okay, I hope it is clear. I hope it is clear. RTH into C, 10 raised to power minus 3. Why 10 raised to power minus 3? Because 10 raised to power minus 6 for C and 10 raised to power 3 for R. Now this 9 will cancel with this 2 and you will get 68 millisecond. Answer is Agra. Okay, answer is Agra. So the time constant for this circuit is 68 milliseconds. So it's very simple. Ultimately, you need to calculate the time constant. Let's come to the next question. Now you can see that in network theory, questions are simple, but it takes time. That's why you should avoid solving network theory at the first stage. It will take your time. Okay, things are very simple, but they are taking time. Now let's come to this question. Now in this question, we need to calculate this voltage. We need to calculate this voltage. So the circuit is provided to you. We need to calculate this voltage. How to calculate this voltage, guys? It's very simple. There is one independent source. Though it is shown in the dependent form, it is shown in the diamond shape, but actually it is independent. You can see the value 5 ampere. If all the sources were dependent, then this answer would be 0. But this is independent, na? That's why you'll get this answer. Now how to calculate this answer? It's very simple. Let's first name them, because we don't know which one is parallel, which one is series. So better you name it. Let's call it A. So this point will become B. Sorry, this point will also become A because it is sorted from here. And this point will also become A. Okay. If this point is A, this point will also be A, this point will also be A. If I call this point as B, this point will also be B and this point will also be B. Okay, so every node is, I have put the naming on every node. Now let's simplify this circuit. How to simplify? From A to B you have one resistance of 25 ohm. Okay, from A to B you have one resistance of 25 ohm, and then from A to B again, from A to B you have dependent source, and the dependent source is entering into A. Okay, and it is 0.2 V1. 0.2 V1. This side is A and this side is B. Now again from A to B there is a resistance of 10 ohm. There is a resistance of 10 ohm. And then again from A to B there is a current source of 5 ampere, independent current source. But this current source is directed towards B. You can see that this is 5 ampere and the current is entering into B. Okay. And there is one more resistance of 100 ohm. So I have connected 100 ohm. This is 100 ohm. Okay. And it is given that this voltage is V1. And on this voltage, this source is dependent. Okay. This source is dependent on this voltage V1. And we need to calculate the value of V1 itself. Now how to do this? How to solve this problem? It's very simple. What you can do is, you can assume a reference voltage. So you can assume this side to be the reference voltage. If this is the reference voltage, then this will become V1. This will become V1. Why? Because you know that this side is 0. So if you are going from minus to plus, this voltage will increase and this point voltage will become V1. Now you can apply direct nodal. You can apply direct nodal. How to apply nodal? Tell me, guys. The coefficient of V1. What is the coefficient of V1? Tell me. The coefficient of V1 is 1 by 25 plus 1 by 10 plus 1 by 100. Okay, and that is equal to entering current. Entering current in this node. How much current is entering? This current is leaving. So it's minus 5 and this current is entering 0.2 V1. Okay, so this way you can write the nodal. And now you can calculate V1 very easily. Okay, so now V1 is, what is this? It is 0.04, I suppose. Okay, 0.04 plus 0.1 plus 0.01 minus this 0.2 is equal to minus 5. Okay, the coefficient of V1 I have written, and this positive value will come on this side and it will become negative. Now you can see that this value will be, what is the coefficient of V1? Coefficient of V1 is minus of, tell me guys, it is 0.05, 0.05, wait a minute, 0 plus 0.05. This value and this value I have added, plus 0.05 minus 0.1, and that is equal to minus 5. Okay. Now from here you can see that it is negative value. It is minus of 0.05, and that will go into the denominator. The minus minus will cancel and it will become 100. Okay. So answer is Agra. Answer is Agra. Okay. So answer is Agra. It's very simple. Question was very simple, and there was nothing in this question. I hope you got my point. Let's come to the next question, guys. Now in this question I want you to try. I want you to try this question. It's a very simple question again. Let's read the statement. The switch S1 is closed at t equal to 0 and S2 is open at t equal to 0. It means previously it was closed, it was open. So it was closed and it was open. So there was no current in this circuit because this circuit was open. The source was disconnected. So there was no current in the circuit. Okay. There was no current in the circuit. Now what is happening is I am opening this switch and I'm closing this switch from here, and it is open from here. Now the circuit is like this. Now this is the circuit. Now this circuit will work. So we have 100 volt, and we have 150 ohm in series with 0.3 Henry. In series with 0.3 Henry. Okay. So this is the circuit we have, and what I need to do is the current flowing through the inductor of 0.3 Henry at 8 millisecond. At 8 millisecond I need to calculate the current. So what is the expression for the current? IT will be equal to, we know that the initial current has to be 0 and the steady state current has to be 100 upon 150. Okay, steady state current is 100 upon 150. Now the expression for the current is I infinity 100 upon 150 plus I0 minus I infinity into e to the power minus t by tau. Now what is tau? Tau is L by R equivalent. So L is 0.3 divided by 150. This is my tau, L by RTH. Okay, if you calculate this, it will become 1 upon 500. Okay, you can see that it will become 1 upon 500. So I can put the tau value. So now the current expression is 100 upon 150 1 minus e to the power minus this tau is 1 by 500. So minus 500t. Okay, this is the expression for the current. If you got this expression of the current at t equal to 8 millisecond, you need to calculate this value. Okay, so at 8 millisecond you can calculate, you can put 8 millisecond here. So 10 by 15 1 minus e to the power minus 500 into 8 into 10 to the power minus 3. Okay, so it will become 10 by 15 into 1 minus e to the power minus 4, I suppose, because it will become 4,000 into 10 to the power minus 3. So it will become e to the power minus 4 is approximately 0. It is approximately 0. So almost answer is 10 by 15. 10 by 15 means 2 by 3. 2 by 3. And if you divide this 2 by 3 and if you calculate this in milliampere, then the answer will be approximately this value. Okay, I think this Agra is correct. You are getting this value. Okay, you are getting this value, I suppose. Please check it. Please check the calculation. Let me check my answer. Okay, for this question I don't know whether I have done it correctly or not, but I think everything is simple. Okay, steady state current is 100 upon 150. That's correct. So everything is fine, guys. Okay, now tau is equal to L by R. So L is this, R is 150. So it will become 1 by 500 minus 500t. That's correct. And at t equal to 8 milliseconds, so I have put this 8 millisecond here. 8 into 10 to the power minus 3. Okay, I think it's correct. You can calculate this value. Okay, in milliampere, I suppose it should be 65 milliampere. Please check this value. Please check this value. It's your calculation part. So let me check my answer also, because I have already done this calculation. So just give me 1 minute so that I can check my calculation also. Okay, please check your calculation. What is the answer for this question, guys? Tell me. You should do the calculation. Okay, So in network theory, this is the bad point. I mean, at every question you have to do calculation, and calculation takes time. Okay. So answer is 0.65 ampere. It's not milliampere, guys. It's not milliampere. That's the reason. Okay. That's the reason I took. Okay. So answer is 0.66, something like that. It means 0.65. Answer is Agra. Okay. This is the correct answer. Okay. Let's move ahead. Let's move to the next question, guys. The next question on your screen is this. The transmission parameter of the network given below represented in the matrix as the form A, B, C, D. Calculate the transmission parameter B of this matrix. How to calculate B? If I open this matrix, I know that VS IS is equal to A, B, C, D, VR into IR. Okay? And we need to calculate B. Now, how to calculate B? Tell me, guys. How to calculate B? It's very simple. Vs is equal to AVR plus BIR. If somehow you can calculate the coefficient of IR in this equation, it will be B. It means first you have to write Vs in terms of VR and IR. We know that this current is IR and this voltage is VR. So if this voltage is VR, then this current has to be VR by 4. Okay, and this is IR. So this current has to be IR plus VR by 4. Fine. And this voltage is Vs. Okay. Now you can apply the KVL. Now you can apply the KVL. At this point you have this VR voltage. You have this VR voltage plus this voltage because the current is flowing in this direction. If current is flowing in this direction, current multiplied by this reactance will be the voltage. So you can see that Vs is equal to VR. VR means this voltage plus this voltage minus J2 into this current is IR plus VR by 4. Now we know that in this Vs equation, so this is the equation like this. This equation is in terms of VR and IR, and we want the coefficient of IR only. So the coefficient of IR is minus J2. Okay. So B is minus J2. This question was again very simple. Okay. So answer is minus J2 ohm. Answer is Bombay. Let's come to the next question, guys. The next question on your screen is, consider the RLC network shown below. The average power absorbed in the inductor. Inductor never absorb any power. Okay. Inductor and capacitor never absorb any power. Answer is Calcutta. It is the resistor only which absorbs the power. That's why the answer is Calcutta. This was very simple question. Let's come to the next question. The next question on your screen is, okay, so this is lengthy question again. What I need to do is the total number of possible trees corresponding to the network shown. So this is the network shown, and we need to calculate the possible number of trees. Now, how to calculate the possible number of trees? To calculate the possible number of trees, I need to find its incident matrix. Okay. I need to find its incidence matrix, and to get the incidence matrix, what I need to do is I need to draw its graph. Okay. Once I get the graph, let me check the correction also. If there is no correction in this question. Okay. Yes, there is no correction. Okay, guys. So what I need to do is I need to draw its graph first. Okay. Now, to draw its graph, what I can do is, you can combine these two for the time because you are not changing the number of nodes. Look at the number of nodes. This is number 1, number 2, number 3. The number of junctions actually. So there are 3 junctions. So you cannot change the number of junctions. Okay? You cannot change the number of junctions. While applying the source transformation, the number of junctions should remain same. So what I'm doing is, I'm merging this. Okay? This current source I am converting into voltage source. So if you are converting this current source into voltage source, the circuit will look like this. The circuit will look like this. We have a resistance and a voltage source, and you can see that I am not changing the number of junctions. I am not changing the number of junctions. The number of junctions are same. Okay, so there are 3 junctions. This, and this. Now what I can do is I can draw a graph. Let's call this junction as A, B, C. Okay. So there are three junctions A, B, C. This lower point is A, this point is B, and this point is C. So now you can see that there is one branch connected here, one branch connected here, one branch connected here, one branch connected here. There is one more branch connected here between A and C. Okay, so I have drawn its graph. Once you have drawn its graph, then you can put the arrow. The arrow can be in any direction. It's your choice. Okay, arrow can be anything. It's your choice. Now what I need to do is I need to write. Let's call this branch as 1, 2, 3, 4, 5. So actually there are 5 branches. You can see that. Now I need to write the incident matrix. In incident matrix, the column is 1, 2, 3, 4, 5. The column represent the branches, and the row represent the node point. I am writing a incident matrix AI. So I told you the column represent these branches 1, 2, 3, 4, 5. These are the column, and the row will be represented by the node ABC. ABC. Okay. This is the way I need to write. Now here I need to put 1 and minus 1. Look, the branch 1. The branch 1 is leaving from A and entering into B. Okay. So I have to write 1 here and minus 1 here. Okay. Wherever it is entering, put minus 1 there, and wherever it is leaving, put 1 there. Okay. So it is leaving from A. So I have put 1 here, and it is entering in B. I have put minus 1 here. Now come to branch number 2. In branch 2, it is leaving from B, entering into C. Branch 2, it is leaving from B. It is leaving from B and entering into C. Okay, entering into C. Okay, now let's come to branch 3. In branch 3, it is entering into B, leaving from C. If it is leaving from C, it has to be plus, and entering into B, it has to be minus 1 here. Okay. Now branch number 4, leaving A, entering C, leaving A, entering C. Okay. Now branch number 5, you can see that leaving from C, entering into A, leaving from C, entering into A. Okay. So you can see that this is my incidence matrix. Now what I can do is I can reduce this last row. Okay. I can reduce this last row. We call it reduced incidence matrix. We call it reduced incidence matrix, AR. AR is this matrix now. It is the reduced incidence matrix. You'll get AR. Now how to calculate the number of trees, total number of trees? So you'll have AR, and now you take AR transpose, multiply them and take the determinant. Okay. Whatever matrix you will get, AR into AR transpose, whatever matrix you will get, take the determinant. Okay. So this is my AR matrix, and the transpose of this matrix is, if I take the transpose, it will become 1 minus 1, 0 1, 0 minus 1, 1 0, and minus 1 0. Okay. So you can calculate this as a, if this is AR, this will be AR transpose. You just multiply it, you will get some matrix, take the determinant of that matrix, and you will get the answer as 8. Okay. Answer is Calcutta. Okay. So answer is Calcutta. Okay. I mean, you can solve it. It's a lengthy calculation. So I mean, it's not that much lengthy, but you have to be very fast in calculating. Okay. Otherwise the time is limited. Okay. Let's come to the next question, guys. The next question on your screen is, consider the circuit shown below, the power factor of the above circuit seen by the source. What is the power factor? You know that the circuit contains capacitors, so power factor cannot be lagging. Power factor cannot be lagging. Okay. So lagging part is over. Now, if somehow we can calculate the impedance of this network, with the help of impedance, you can calculate the power factor. Okay. So let's first calculate the impedance. How to calculate impedance? These two are in parallel and this is in series. So what I can do is 6 plus the parallel equivalent of these two values. So parallel equivalent is 4 minus J1 divided by 4 minus J1. Okay. Now further simplify it. So it will become 4 plus, in the numerator you will have minus J4, multiply by 4 plus J and divide by 4 plus J. Okay, so I am realizing this 4 plus j multiplied and divided. So in the denominator you will get 17. Okay, 4 square plus 1 square, that is j square. Okay, 4 square minus j square, so you will get 17 here. Okay, now it will be 4, and you can see the real part is 4 by 17, and the imaginary part is minus j 16 by 17. Okay, so you can see that this quantity is approximately 6 point something, and this quantity is approximately 0.9 something. It means the real part is much greater than the imaginary part. So power factor will be leading, that's for sure. Power factor is leading, that's for sure, and it will approach to 1 because the real part is more than the imaginary part. If real part and imaginary part equal, then the power factor is 0.707. If the real part is greater than the imaginary part, then the power factor will be towards unity side. Okay, so now in leading, this cannot be correct answer. Answer is Bombay. Okay, answer is Bombay. So directly you can calculate. There is no need to apply calculator, or no need to check cos phi from here, or angle, no need to calculate angle from here. Okay, so you can directly tell the answer, okay, using this impedance value. Let's come to the next question. Now in this question you can see that we have a coupled circuit. Okay, we have a coupled circuit, and we need to calculate the equivalent inductance between A and B. So again, it's very simple. What you can do is, we know that, let's draw the current first. I'm showing the current. Now we know that whenever two coils are coupled, okay, let's call it L1, L2, and the coupling inductance is M. Then L equivalent will be equal to L1 plus L2 plus 2M in this case, because current is leaving from both the dots. If current is leaving from both the dots or entering in both the dots, then I have to take plus sign here. But if current is opposite, it's like this. In one coil it is entering, in one coil it is leaving the dot, in one coil it is entering in the dot, then the equivalent inductance will be equal to L1 plus L2 minus 2M. Okay, L1 plus L2 minus 2M. This is my equivalent inductance. Now you have to apply the same concept here. So what I'm doing is, I need to calculate equivalent inductance. So you can start from A. First, this is 6 Henry. And what about this? This is 8 Henry. So let's first cover these two. This is 6 Henry, this is 8 Henry. So I have added these two values. Okay, L1 plus L2. And you know that from dot the current is leaving, and here in the dot current is entering. So I have to write minus of 10. Okay, minus of 10. Fine. Okay, now let's come to these two coils. So I have to write 8 plus 10, but 8 is already taken care. 8 is already considered in the first two coils. 8 is already considered. So 8 plus 10, and you can see that current is entering here and current is leaving here. So I have to write minus 8. Okay, L1 plus L2 minus 2M. Now again L1 plus L2 minus 2M. Now L1 is already taken care. Na? You can't take L1 twice. Okay, in series network you can't take L1 twice. So now you can see that 8 is already taken. I have to take 10 and minus of this 2H. Okay, so minus of 8. Now you have to come to this coil, these two coils. So 6 is already taken, 10 is already taken. Only thing is this mutual inductance is not considered. And we know that from this dot current is leaving, from this dot also the current is leaving. So you have to write plus 2M plus 4. Okay, so this is my L equivalent. Now you can calculate this sum. Okay, this sum came out to be 10. Answer is 10 Henry. Okay, this was a simple question. I hope you got the point how to calculate the equivalent inductance here. Let's come to the next question. Consider the resistive network shown below, the value of the Norton current across the terminal AB. So Norton current is the short circuit current. I need to calculate the short circuit current from A to B. This current I need to calculate. So you can sort it. Okay. Now if you are sorting it, then what is this current? Obviously this resistance is of no use now. Okay. This resistance is of no use, and you can combine these current source. You can transform this current source. Okay. So what I can do is from A to B, there is a short branch. I need to calculate this current, I Norton. And on this side, I can combine these two branches. So the resistance will be in series, and you have one voltage source as 12 volt. Okay. Now on this side, again, you have 6 ohm, 3 ohm and 120 volt. So you can write them directly. You can write them directly, or, okay, let's write them directly. So you have 3 ohm and 6 ohm in series with 120 volt. 6 ohm in series with 120 volt. Fine. So this is the circuit we have. Now in this circuit, I need to calculate this current. How to calculate this current? This current is this branch current. Using nodal, you can calculate the current using nodal. So let's apply nodal. For nodal, let's say that this is neutral point, ground, and let's call it VA. So what is the coefficient of VA in nodal equation? Coefficient of VA is 1 by 2 plus 1 by 3 plus 1 by 6. 1 by 2 plus 1 by 3 plus 1 by 6 is equal to entering current. So because of this 12 volt, current will be minus 6. And because of this 120 volt, current will be minus of 20. Okay. So now you will see that this value came out to be 1. This is half. Okay. And this is half. So VA came out to be minus 26. This voltage is minus 26. Now we need to calculate this downward current. How to calculate? You can start from the upper point. Minus 26 minus 12 divided by the resistance 2. Okay. The resistance 2. So this way you can calculate the current, but the current you are getting a different answer. Let me check whether I have done it correctly or not. Is there any mistake? 1 by 2, that's correct. 1 by 2 plus 1 by 3 plus 1 by 6, that's correct, is equal to entering current. So 120 by 6, 120 by 6 is 20, and it is entering. Okay, I made a mistake. It should be plus here. Excuse me. It should be plus. Entering current, yes. Entering current, this will enter, try to enter 20 ampere. It will try to enter 6 ampere. Thank you. So now VA is 26. So now you can apply this. 26 minus 12 by 2. 26 minus 12 by 2. What is this value? This value came out to be 14 by 2. And 14 by 2 is 7 ampere. Answer is Calcutta. Okay. Let's come to the next question. Which of the following is false for a thyristor? Okay. I need to calculate the false statement for the thyristor. Which statement is false? Okay. Which statement is false? I need to calculate that. Now, how to calculate? For a thyristor, first of all, in thyristor, I mean, you have to remember it. In thyristor, you can turn on using gate current, but you can't turn off using gate current. And here it is written, the negative value of the gate current, turn off the thyristor. This is wrong. This is false. It means in the option, B should be there. In the option, B should be there. So in A, B is given, B, option B, B is given. In option C, B is not given. This cannot be true. Okay. This is a false statement. This is a false statement. Now let's come to B and C. The forward bias portion of the thyristor IV characteristics. If you look at the thyristor IV characteristics, it will be like this. For thyristor IV characteristics, the characteristics will be like this. And you can see that this is the stable zone and this is the unstable zone. Okay, this from this point to this point, you have unstable zone. Okay, from this point to this point, you have unstable zone. Okay, and this is again a stable zone, because you can see that. Why I am calling it stable? Why I am calling it stable? Because if you are increasing V, current is increasing. In this range, if you are increasing V, the current is decreasing. That's why it's an unstable zone. Okay, this is unstable zone. So for the forward bias portion of the thyristor IV characteristics, in this forward bias zone, IV characteristics has one stable operating region. Actually, it has two stable operating region. It has two stable operating region. So C is false and B is true. Okay. So B should not be in the options. B should not be, because B is true. It has two stable regions. C is false. So the option which contain B That cannot be true. That cannot be correct. That cannot be, because we want false statement. And B is a true statement. It has two stable regions. So B cannot be the correct answer. It means B should not be there. So in option A, B is there. In option B, B is there. Okay. Wait a minute. False statement. Wait a minute. Wait a minute. Wait a minute. Excuse me. So we need to calculate the false statement. So D is false. We know that. D is false. So if D is false, then A cannot be correct. D cannot be correct because we want false statement. The negative gate current turn of the thyristor, it's a false statement and we want the false statement. It means A cannot be correct and D cannot be correct. Either BC, A and D option are wrong. Either B option is correct or C option is correct. Now let's come to the next. Between these two options, I told you that it has two stable operating regions. This is the correct statement. We want false. So out of B and C, C should be there in the answer. So between these two options, this option contains B. This cannot be the right answer. This is the right answer. Why it is the right answer, guys? Why? Because it doesn't contain the option B. It doesn't contain the option B because B is the true statement. So the false statement is C. Okay. This is the false statement. So D is false, C is false, and A is also false. Okay. So that's why C answer is correct. Okay. So you have to remember it. There is no other choice because for EC student, ultimately you have to memorize it. Let's come to the next question, guys. In the next question, so it's from this question is from control system. The asymptotic body plot for a gain for the gain magnitude of a minimum phase system. So the asymptotic body plot is given. The steady state error. How to calculate the steady state error? It's very simple. Whatever the first line of the body plot, check the height of the first line. Check the height of the first line at omega equal to 1. This point will give you 20 log kV, 20 log error constant. Okay, remember this point. In a type, this is a type 1 system, we know that, because there will be 1 by S in the denominator. There is 1 S in the denominator. It means it's a type 1 system. And in type 1 system, the velocity error constant, how to calculate? I told you that whatever the first line is, the height of the first line at omega equal to 1 will give you 20 log kV. From there you can calculate kV. So this height is already given to us. So 20 log kV is 20. It is given as 20. Okay, so kV came out to be 10. If you get kV as 10, then the steady state error is 1 over kV, 0.1. Okay, 0.1. Answer is Bombay. Let's come to the next question, guys. The next question on your screen is, identify the converter topologies from the figure given below. So there are two topologies. Both are converter. Okay, both are DC-DC converter. Okay. Now, in this converter, you can see that on this side there is no choke coil. Here you have the choke coil. So whenever in DC-DC converter, if it has choke coil, we call it forward converter. Okay. And in this, there is no choke coil here, so it is called flyback converter. Okay, so I think A is correct. 1 is flyback converter and 2 is forward converter. You have to remember it like this. Okay, so 1 is flyback converter, other one is the forward converter. It's DC-DC converter. It's making DC to DC. Just remember this line. Let's come to the next question, guys. The next question on your screen is, consider two control system with following transfer function. This is the transfer function 1. This is the transfer function number 2. Okay. Now, which one of the following is true? Bandwidth of the system 1 is greater than the bandwidth of system 2. How to check the bandwidth? It's very simple. If you draw its body plot, the body plot will look like this. Body plot will look like this. It is minus 20 dB per decade. Okay, roughly like this. So what I'm doing is I'm writing it like this: 1 over S divided by 1 by 3 plus 1. And I'm drawing its body plot like this. So up to this point, the gain is unity, 0 dB. 0 dB means actual gain is unity. And now it is decreasing with minus 20 dB per decade. It means this is the corner frequency. This is known as the bandwidth of the order 1 system. Okay. So the bandwidth in the first case is 1 by 3. Bandwidth in the first case is 1 by 3 because at this frequency, actual Bode plot is like this. It means at this point, it's 3 dB down. It's 3 dB down. So this is the bandwidth of this first order system. If I take it as a filter, then up to this point, the gain is almost unity. Okay, after that the gain is decreasing. So this is the corner point, you can say. So the bandwidth of this system 1 is 1 by 3, and the bandwidth of system 2 is 1. Okay, the bandwidth of system 2 is 1. Now you can see that the bandwidth of system 1 is greater. No, the bandwidth of system 2 is greater than the bandwidth of system 1. Bombay is correct. Okay, Bombay is correct. Let's come to the next question. The next question, you can see that GS is given to you. Okay, and there is a unity feedback, negative feedback. Which of the following is true for the system to be stable? We want that the system to be stable. What is the value of K so that the system remains stable? So you can apply Routh criteria. Okay, first you need to write characteristic equation, and the characteristic equation is 1 plus GSHS. Okay, S into S plus 2, S plus 4, HS is 1. Okay, so I'm not writing HS. 1 plus GSHS equal to 0. This is my characteristic equation. You can simplify this. It will become S cube plus 6S square plus 8S plus K equal to 0. This is my characteristic equation. Now you can apply Routh. Okay, and the coefficient is 1 here. This is 8, this is 6, this is K. Okay, 6 into 8, 48 minus K divided by 6, and this is 0. Here you will get K. Now to make the system stable, wait a minute, have I done it correctly? S into S plus 2 into S plus 4. So it will become S cube plus, what is the coefficient of S square? 2S plus 4S, 6S square. That is correct. 8S plus K. I think it's correct. Okay, I think it's correct. Now you can see that to make the system stable, this has to be positive. All the term has to be positive. It means this K should be greater than 0 and K should be less than 48. Then only it will be positive. Okay, K should be less than 48. So the overall range is K should be greater than 0, less than 48, and it is mentioned nowhere. So the answer is Delhi. Okay, answer is Delhi. None of these. Okay, so please check it. This was a simple question. I hope my calculation is correct. Okay, so this way you can solve the problem. It's easy peasy. Let's come to the next question. Question number 33. The peak overshoot and the second undershoot, the third peak overshoot and the second undershoot of a step response of the second order underdamped system. Okay, so we know that the step response of a second order underdamped system is like this. It is like this, and the third peak overshoot. What is third peak overshoot? This is the first overshoot, this is second overshoot, this is the third overshoot. At what time it is there? At what time it is there? So we know that this is the peak time, and how to calculate peak time? Pi by omega d. So this is 2 pi by omega d, this is 3 pi by omega d, this is 4 pi by omega d. So this will be 5 pi by omega d. It means the third overshoot will occur at 5 pi by omega d. So we need to calculate this height, this overshoot height. Okay, now how to calculate this overshoot height? In the expression of yt, you have to put this value. You will get this height. Let's say you put this value to get the first overshoot. So in the expression of yt, you put t equal to this value and calculate this entire height minus this height 1. Okay, this way you calculate the overshoot. So the first overshoot came out to be e to the power minus pi zeta divided by root of 1 minus zeta square. This is the first overshoot. Now the second overshoot, you have to put 3 here, because you know that this time is 3 pi by omega d. So here you will get 1 extra 3 factor. Now for third overshoot, you will have 5 here. It means 5 pi zeta divided by 1 minus zeta square is the overshoot value, third peak overshoot. So third peak overshoot is, you can see that this is the correct answer. Okay, minus 5 epsilon pi divided by 1 minus minus 5 zeta. In place of zeta he is writing epsilon. Minus 5 zeta pi divided by root of 1 minus zeta square. This is the third overshoot. Now what is the second undershoot? You can see that this is the second undershoot. This is the first undershoot, this is the second undershoot. So second undershoot occur at 4 pi by omega d. 4 pi by omega d. Okay, at this instant, second undershoot occur. So here it should be 4. So answer is Delhi. Okay, directly you can write like this. This is the first overshoot. For first undershoot, you have to put 2 here. Okay, you have to put 2 here. I hope it is clear. Okay, I hope it is clear. So this way you can solve the problem. It's easy peasy. Now let's come to the next question. Wait a minute. Which was there? Okay, let's come to this. Consider Nyquist plot of a second order system. So we have the Nyquist plot, second order underdamped system shown in the figure below. The resonant frequency corresponding to Nyquist plot. What is the resonant frequency? At the resonant frequency, the magnitude of Gj omega has to be highest, okay, or Tj omega. You can call the second order system as Tj omega. You know that if I plot omega with respect to omega, then the second order system will be like this. This is known as the resonance frequency. So at resonance frequency, the magnitude of this function has to be the largest. And in polar plot, the magnitude can be shown from the distance from origin, okay. Now you can see that at this point distance from the origin is this, from this point distance from origin is this, and distance from origin is this. So these lines will represent the magnitude at different frequency, which has the highest value. Now it can be at omega 3 or omega 2, but according to graph I think omega 2 is highest. That's why the resonance frequency has to be omega 2, okay. According to the graph, the resonance frequency has to be at omega 2, okay. Let's come to the next question, guys. Let's come to the next question. The next question on your screen is, the system is to be compensated, okay, so it has to be compensated such that the gain crossover frequency becomes same as uncompensated phase crossover frequency. This is uncompensated system, so we need to compensate it such that its gain crossover frequency become equal to phase crossover frequency. Which of the following is the phase crossover frequency for the compensated system? Actually, we don't know the compensated system, so it will not be possible for us to calculate the frequency of a compensated system, okay. For a compensated system, we can't calculate the frequency of the phase crossover frequency. For uncompensated system, we can calculate. For uncompensated, this is the uncompensated system, and if you want to calculate the phase crossover, then what you can do is you can calculate the phase of this function, minus 90 minus tan inverse omega minus tan inverse of omega by 16, and put it equal to minus 180. So you'll get omega as 4. At omega equal to 4, this condition is satisfied. So at omega equal to 4, you will get the phase crossover for uncompensated system. For compensated, we cannot calculate. So I hope there is a error in writing. It should be uncompensated system. Answer is Agra. Okay, answer is Agra. Let's come to the next question, guys. Let me check how many questions are there. Okay, only 2 questions are there. So maybe after next question, I'll call Rathi sir so that he can continue from this point onward. Okay, guys. So now let's come to this question. The number of feedback loop of the signal flow graph. So we need to calculate the number of loop. So tell me, guys, how many loops are there? Everyone, tell me how many loops are there. Tell me. Now it's your turn. It's your question. You can calculate the number of turns. Until then, you can calculate the number of loops. Until then, I can call Rathi sir so that he can continue from this point onward. So please wait. Let me call Rathi sir. Okay, guys, so Rathi sir is ready, and now tell me which option is correct for this question. Which option is correct for this question? The number of loop we need to calculate. So this is the loop number 1. This is loop number 2. Here you will get loop number 3. This is loop number 4. and there it is, loop number 5. Okay, so there are actually 5 loops. There are actually 5 loops. No, this is not the loop. Okay, so 5 loops are there, because there is one more answer, no? 6. But I think 6 is not there, no? One more loop. Can you find one more loop? You go like this and this and this and you can't come. Okay, only 5 loops are there. Okay, answer is Calcutta. Answer is Calcutta. There are only 5 loops. Okay guys, let's come to the next. From the below given Nyquist plot, calculate the number of open loop pole on the right hand side of the S plane for the closed loop system to be stable. It is given that the closed loop system is stable. Now you can see that this is minus, somewhere -1 will lie here. Okay, and the number of encirclement of -1 is 1. Number of encirclement of -1 is 1. There is Z minus P or P minus Z, whatever. It is given that the system is stable. You can write 1 as P minus Z or Z minus P. Okay, we don't know the direction of the contour, so S plane contour, we don't know. So better you write it like this or this. Now we know that the system is stable. Closed loop system is stable. If closed loop system is stable, Z has to be 0. So P is 1. This is the poles of GSHS, open loop poles. Okay, these are the open loop poles. Remember, actually these are the poles of 1 plus GSHS, but we know that the poles of GSHS and 1 plus GSHS are same. Okay, that's why you have calculated the poles of 1 plus GSHS, and Z is the zeros of 1 plus GSHS, and Z represent closed loop poles. These zeros of 1 plus GSHS represent the closed loop poles, if you know Nyquist plot. So don't worry guys, this Z, since the system is stable, it means there is no pole in the right half of the S plane. There is no pole of 1 plus GSHS in the right half of the S plane. And the poles of the poles of the closed loop system can be represented by zeros of this. It means there is no zero in the right half of the S plane. Now this P represents poles of this function, and poles of this function and this function are same. So open loop poles are 1 in the right half of the S plane. Okay, and it is asked about the same. Calculate the number of open loop poles on the right half of the S plane. So the answer is 1. Okay, answer is 1. Answer is Agra. I hope it is clear. So now I have covered total 37 questions, you can see. Okay, and I have covered network theory, power electronics, and control system. Okay, so these topics I have covered. I hope you understood all these questions. If there is any doubt in these questions, you can comment in the comment section. Okay, so that's all for today's session guys from my side. Now from this point onward, Rathi sir will continue. Let me ask Rathi sir whether he is available online or not. Okay, so just give me 1 minute guys.
Hello everyone, very good afternoon and welcome to the BYJU'S exam prep, the most comprehensive app for all competitive exams. Let me know that sound quality, picture quality, everything is fine. Yes, please. Yes, please inform me. Okay. I will continue with what EDC and analog. As you know that EDC and analog are very important subject for what ISRO examination. So quickly we will solve questions. So Chinmay, how are you? Risit, Ghosh, everything is fine. Now I am going to solve some important numericals. That is electronics and telecommunication ISRO 2020 previous year question paper. This is also important for what electrical students. Okay guys. Now first question without any delay. In a semiconductor device, if the Fermi level is positioned at conduction band, that is the question on Fermi level. As you know, the Fermi level is a very important one. Definitely there will be the questions on what Fermi level. Chinmay, research, let me know that sound is perfect. Yes, please. 1 minute. Hello. Okay. Now, I'm going to discuss first question. In a semiconductor device, if Fermi level is positioned at conduction band, right? Determine the approximate probability of finding electrons in state at EC plus KT, where K is the Boltzmann constant and T is the device temperature in Kelvin. Okay. Then remember, what is the formula for the Fermi level? Fermi energy, Fermi probability, it is given by 1 upon 1 plus e raised to power, that is the energy state, minus EF by KT. EF by KT it is given. Okay. Now what is the E is given? E is energy level, E is given as EC plus KT. Probability of finding electron in the state EC plus KT. Now when I am putting the EC, E is equal to EC plus KT, it will become EC plus KT, right? And what? Now what is given here? Determine the approximate probability electron, and Fermi level is positioned at conduction band. EF is equal to EC. Positioned at conduction band. So EC cancel, KT by KT it will become 1. What is the answer? 1 upon 1 plus e raised to power 1. 1 upon 1 plus e raised to power 1. And then you can find with the help of that value. As you know, 1 by E is what? 0.368. Then you can find the e raised to power 1 and then put the value here, you will get the 0.27. What is the answer for this question? 0.27. This is the standard formula for probability of finding an electron at particular energy level. This is the first question. Now second one. Again that is the question on energy band diagram. Okay, tell me what is the answer. For the following energy band diagram, determine the approximate resistivity. This is very important one. X greater than L. X, this is the X minus L, X is equal to 0 and X greater than L. Now watch this portion only. Here this is the intrinsic Fermi level, this is the conduction band, that is the Fermi level, and Fermi level is near to what? Valence band. When the Fermi level is near to valence band, this is means what? This is the P type. So here it is P type, in between it is N type, here again it is a P type. And what is the gap between EI and EF? EI and EF is given as EG by 4. EI and EF is given as EG by 4. To get the data, EG is given here, T is given here. Now mu n is given, mu p is given. For the following energy band diagram, determine the approximate resistivity for X greater than L position of the semiconductor. Now at this position it is P type, that's why the conductivity is given by PQ mu P. Why? Because it is a P type. And what is the resistivity? 1 by sigma, 1 by rho. This is the rho is equal to 1 by sigma. Now what is the concentration of P? Yeah, right. What is the gap here? EI minus EF. What is given here? NI is given to EI minus EF. This gap is EG by 4. EG by 4. What is the EG? 1.12 divided by 4. 1.12 divided by 4. Now this gap, EI minus EF, is given by KT log of P by Ni. KT log of P by Ni. Remember this diagram. This is the EV. This is EF near to EV, that's why it is a P type, and this is EI, intrinsic Fermi level, and that is the conduction band, EC. This is the conduction band and that is the valence band. Fermi level is near to EV, that's why it is a P type, and this gap is given by EI minus EF, KT log of P by Ni. From this you can find the P, guys. Okay, to EI minus EF by KT, and take the what is the EI minus EF, you can find from that, then divided by the KT. It is given in the value, that is the K, that is the Boltzmann constant at 300 degree Kelvin. As you know, you can put the value 300 degree Kelvin, 0.026. 0.026, you can put this value, and then mobility of hole you have to use. Mobility of hole you have to use. That is, they have given us 400 centimeter square. So 400 Q 1.6 into 10 raised to power minus 19. P you can find from this value, right? Ni is given, EI minus EF is given, that is the Eg by 4, and then you will get the answer. I think that D is the answer for this particular question. Okay, again, that is a question, guys. Directly, anyone, please give me the comments that everything is fine now. Okay. Everything is fine now. Okay. The next one. So that is the answer, 31.25 ohm centimeter. This is the unit of resistivity, and these are the important formula. Okay, so you can use this formula here. Then which one plot gives the closed resemblance to the stability? So there are three stability factors. What are the stability factors? S, S dash, S double dash. So normally we are getting the question on S. S means change in IC because of change in ICU. When the beta and VB kept constant. Beta and VB kept constant, that is called stability factor. Resembles to the stability of emitter bias configuration of BJT with respect to RE upon RB. RE is the emitter resistance and RB is a base resistance. Okay. Now, that is the value. As you know, S, we have find the value 1 plus beta upon 1 minus beta DIB by DIC. DIB by DIC, that is the formula, standard formula for stability factor, guys. Okay. Or now this DIB by DIC, just I will give you the diagram for self-biased circuit. This is the diagram for self-biased circuit. Quickly we will solve this question. This is called RB. Here we are connecting the supply VBB. Here we are having the current IC plus IB. This current is IC, this current is IB. When we are writing the KVL in this part, this is the VB kept constant. You can write VBB is equal to IBRB plus VB plus IC into RE plus IB into RE. That is the IC plus IB into RE. To write down the KVL. Now differentiate with respect to IC. You will get 0. Then you will get RB plus RE DIB by DIC. RB plus RE DIB by DIC plus RE, because the differentiation of IC is 1, differentiation of VB is 0. So what is the DIB by DIC? It is negative value because there is a negative feedback, RE upon RB plus RE. So everyone, please, you can't derive the formula during exam. So you have to give the value minus RE upon RB plus RE, and already I have given S is given by 1 plus beta upon 1 minus beta DIB by DIC. What is the DIB by DIC? Minus minus, it will become plus RE upon RE plus RB. RE upon RE plus RB. Now, in terms of RE and RB, you can divide it by RE. So it will become 1 plus beta upon 1 plus beta 1 plus RB by RE. 1 plus RB by RE. That is the formula. And when we are giving the approximate formula, when the beta is very, very large, or 1 plus beta Re is very large, it is 1 plus Rb by Re. That is the formula. From that you can find the value. Okay. Now guys, when the Re, try to understand, when the Re is 0, when this Re is 0, this is the in terms of Re upon Rb. When this Re is 0, it will become infinite, that term will become 0, and S is equal to 1 plus beta. When Re is 0. And when Re is infinite, S will become 1. When Re is infinity, that will become 0, beta by 0 will become what, and that is cancel out, and Re will be, this is the Re is infinite, Rb by Re will become 0, 1 plus beta upon 1 plus beta will become S is equal to 1, that is called lowest value. Then, what is the graph here? 1 plus beta when Re by Rb is 0 and final value is 1, and that's why the B is the correct answer for this question. B is the correct answer for this question. Sir, how can I can watch your yesterday's analog class of BYJU'S? At which time? Oh, recorded lectures are available. You can join that. Please follow me then so that you can join. Okay. So this is the answer. Please remember the standard formula. How we can find the value of dIB by dIC. This is also the standard formula. Put the value, put the different values of Re, and then you can find the answer for this question. This is about the self-biased circuit. Okay. B is the correct answer for this question, Chinmay. Then initial, this is the number of questions on MOSFET. Last time number of questions on MOSFET, guys. So please prepare the MOSFET. Okay. Some questions are wrong. Some questions because of the different numerical values we are not getting the right answer. But now initial voltage of the C1 capacitance is 3 volt. Means what is the voltage charge in the C1? 3 volt in the given circuit. Correct sketch of Vx. Remember, what is the voltage? Vx as a function of time. Threshold voltage is 0.5 volt. And here one supply voltage is given that will switch from 3 volt to 0 volt. When this type of signal is given, means for t less than 0 it is 3 volt, for t greater than it is what? 0 volt. Less than it is 3 volt, 3 greater than 0 it is 0 volt. Now Vx versus time. So this is the Vx versus time. From 6 it will drop up to a 2.5 volt. From 6 it will drop up to 3 volt and exponentially decreasing. Here it is 6 to 3 volt it will, and then again decrease, and that's why increases, and that is a sudden change here in the voltage. Okay, one by one we will check. There are two figures for t less than 0. For t less than 0, what is the voltage at source terminal? The source terminal voltage is 3 volt. What is the VGS? VGS is VG minus VS. VGS is VG minus VS. So this is the VG. This is the VS. VG minus VS will become 0. When the VGS is 0 means VGS is less than the threshold voltage, and that's why the MOSFET is in cutoff. It will act as open circuit. When the MOSFET is in cutoff, it will act as open circuit. Then this capacitor has 3 volt. Okay. And this source voltage has 3 volt. Source voltage also has the 3 volt. This is the AC signal 3 volt. Okay. Now, what is the Vx? This is 3 volt, that is 3 volt. This is the Vs. So, Vx initially it is 3 plus 3, it is 6 volt. So, initial value of the Vx for t less than or just 0 plus, just 0 transition. Before transition it is 6 volt. Always remember, capacitor does not allow sudden change of voltage. Now, Vs will suddenly drop to 0. Vs will suddenly drop to 0. When it will drop to 0, then next diagram. Now this is connected to ground. What is the Vg? Vg is equal to 3 volt. And this capacitor is charged up to what? 3 volt. Now, this voltage VGS is 3 volt. And this is greater than the threshold voltage because the threshold voltage is only 0.5 volt. Right? Means it is on. When it is on, almost it will act as what? Short circuit, or it has some very small internal resistance. Yes, MOSFET, RDS, drain to source resistance here. Drain to source resistance, RDS. Linear ohmic resistance and drain to source resistance. Now this capacitor will discharge through this. When this capacitor will discharge through this MOSFET, this is nothing but RC circuit. Source free RC circuit. And finally this Vx, that is nothing but voltage across the capacitor, will become what? 0. Exponentially decreasing function. Guys, this type of graph, initially the Vx was 6 volts, suddenly it will drop to what? 3 volt and then exponentially decreasing function. This is the value of the Vx with respect to time. So from the 6 it will drop to what? 3 volt and then it will exponentially decreasing function. So this is the B is the correct answer for this question. B is the correct answer for this question, guys. Okay, so that is the answer. Time constant is not given, C is not given, resistance is not given. We have to simply give the wave, which type of output. B is the answer. Now tell me next question, next one. Okay, again that is the question on what? For an n-type germanium specimen, width 4 mm, length 1 mm. W is given, germanium specimen. That is the width, W is given. Length it is given. Now 1 mm, a magnetic field perpendicular to the current flow direction. If this is the current, then magnetic field perpendicular to that W or B, and then Hall voltage, that is nothing but Hall voltage 0.1 Weber per meter square, and Hall voltage magnitude is 0.005 volt. Calculate the majority carrier density. Calculate the majority carrier density. Hall voltage, very simple formula for the Hall voltage, that is Bi by rho W. This is the Bi by rho W, where rho is what? NQ, or rho is 1 by rho is called Hall coefficient. 1 by rho it is called what? Hall coefficient. Once you will get the idea about the rho, you can find the NQ. What is the asked here? Calculate the majority carrier. Because it is a N-type, already given it is a N-type germanium specimen, means what? Electron. You have to find the concentration of the electron. Then you have to find the rho. So what is the rho? Is equal to Pi by Vh into W. What is the rho? NQ. Then VHW. So what is the concentration of electron? Pi by Q VHW. B is given in the question, Weber. Hall voltage is given in the question. Width is given 4 mm. Okay. And current is given 1 milliampere. So everything is given. Put the value here. 0.1. 1 milliampere. Remember 0.1 Weber. But be careful about the unit. Milliampere into 10 raised to power minus 3. Upon VH. VH is given as 0.005. Q 1.6 into 10 raised to power minus 19. Right. And W is given as 4 mm. Right. Now remember what is given per meter cube or per centimeter cube. Be careful about the unit, guys. Here Weber per meter square. To convert the 4 mm into what? Meter. 4 mm into meter. 4 into 10 raised to power minus 3. 4 into 10 raised to power 1 mm means 10 raised to power minus 3 meter. Now you can find the value of concentration N. Easy, guys. So that is the question. Okay. But I have given a be careful about the unit, guys. Be careful about the unit. What is the answer, Chinmay? What is the answer you are getting? Tell me. You can find the value here. Easy question, formula based question. So yes. Next one. Next question. Okay. Put the values and then you will find the answer. The Hall effect, this is the Hall coefficient, and that is the formula. Now, that is the question on what IV characteristics of the diode. The following table gives the forward characteristics of silicon diode. Estimate the temperature of a diode junction. Log of 0.2 is equal to this value. VF is given 1 milliampere 5. And then guys, what is the value of the temperature? So what is the new in this diagram? What is the new in this formula? Last year this question was asked in ISRO examination. According to the graph, there is a very fast change. In 0.6 it is 1 milliampere, and in 0.65 it is a 5 milliampere. 5 milliampere through the diode is a large current, guys. Or in a number of sessions I have given, when the current is very, very large, eta is 1 for silicon also. When I am writing the equation for I is equal to I naught e raised to power V by eta Vt minus 1. What we are saying that eta is 1 for germanium and eta is 2 for silicon. For rated current, it is in the range of what, 1 milliampere or 2 milliampere. But when we are saying that it is a suddenly switch from 1 to 5 milliampere, then for very high current again eta is 1 for what, silicon, for high current. In this case you have to consider the eta is equal to 1. Then you can very easily you can solve. Following table gives the forward characteristics of silicon diode. Estimate the temperature of the diode junction, guys. Okay, that. Now, if that is the formula is given for forward value 0.6, you are having the IF is equal to 1 milliampere, then 5, then use 2 times use this equation, then you can find a value. When the current is 1, I naught e raised to power, first voltage is what, 0.6 volt. Eta will become 1, Vt minus 1. Second, this is the 5, I naught e raised to power 0.65 by Vt minus 1. Now, you can put the value of the Vt, volt equivalent of temperature. That temperature, you have to find the temperature, means you have to find the Vt. But remember this term, because the current is very large, you can neglect this term, 1 and 1. Then it will become, it is nearly equal to I naught e raised to power 0.6 by Vt. I naught e raised to power 0.65 by Vt. Because we can neglect, when it is a forward bias, that the value is very large as compared to 1. This value is very, very large as compared to 1. That's why you can neglect 1, you can neglect 1. Now we are having the 2 equation, divide 2 divided by 1. Let this is the equation number 2. This is the equation number 1, divided 2 divided by 1. It will become 5. I naught cancel out, and it will become 0.65 minus 0.5 upon what, Vt. 0.65 minus 0.5 upon Vt. Then 0.65 minus 6 upon Vt, 0.05 by Vt. Take the log of that, that has become log 5, and it will become 0.05 upon Vt. Guys, find the Vt and remember Vt, that is the kT by Q, T by 11,600, and multiply it by 11,600 Vt, and you can find the value of what, T, that is what, 360 degree Kelvin. 360 degree Kelvin. Please check my calculation. Okay. So that is the formula, guys. So with the help of this formula, you can find the value here. Okay. I think you have calculated. Now, next question, I am going to discuss next one. Right. So we have solved one question on MOSFET. We have solved the that is the on Vt. This is the 360 degree Kelvin. So these are the formula. Find the value of Vt, then find the value of the temperature by using this formula. Okay, and that is the answer for this one, B, 360 degree. Next question. Okay, another again on MOSFET. N-channel MOS transistor is made on a P-type substrate with Na is equal to 10 to the power 15. Find the approximate depletion charge QD per unit area for a strong inversion. Depletion charge density for strong inversion. When we are talking about the strong inversion, guys, that complete P-type material is converted into what? N-type. Complete P-type is converted into what? N-type. And what is the depletion charge per unit area at the strong inversion? Then that the value is given log raised to 10, or this is the values, these all are given. But you have to use the formula. What is the formula for the depletion charge density? I think in case of diode, we have the formula that this is the applied voltage in the reverse direction plus built-in potential. This formula is very, very useful. Qn upon 2 epsilon s into W square. That is called the depletion width. That is called what? Depletion width. This is called junction potential VR. This is called the junction potential Vj, VR plus V0. V0 is called built-in potential. Vt log of Na Nd by Ni. Just I am giving you the formula. We will use this formula for next 2 to 3 questions. Now, what is the formula here? Directly I am giving you the formula how we can solve this question. Let QD is given by minus QNAW max. QD is the minus QNAW max. Okay. Then guys, what is the V? Already I have given QNA by 2 epsilon s W square. So what is the W? 2 epsilon s by QNA into V. But at strong inversion, what is the applied voltage? For a strong inversion, the applied voltage is what? 2 times of work function, that is phi f. Now 2 types of work function phi f. What is the phi f? Vt log of Na upon Ni. Vt log of Na upon Ni, where Na is the acceptor impurity concentration, Ni is the intrinsic carrier concentration. When I am giving the, what is given in the question, Na it is given 10 to the power 15, Ni it is given 10 to the power 10. From that, Na is given, Ni is given Vt. What is the Vt temperature? It is given, right? If the temperature is not given, then at the 300 degree Kelvin, you can put the value of the Vt. That is nothing but 0.026. Find the value of phi f. 0.3. Then find the value of 2 phi f. That is what it will become 0.6. Then put the value, right? Put the value in this formula, that is in the terms of what? V. And finally put the value of W. That is called W max. What is the W max here? Root over 2 epsilon s upon QNA into 2 phi f. Then this 2 phi f, same formula you have to put here. Then QNA cancel this out, and finally you will get this final formula. Minus of 4 epsilon s QNA phi f. Phi f, put the 0.3, Na it is given in the question, Q you have the idea epsilon s, that is the permittivity of semiconductor. Which material we are using here? N-channel MOS transistor, P-type substrate. Find approximate depletion charge per unit area at strong inversion. If that is not given, remember, for silicon it is what? 11.7 relative permittivity. And what is the epsilon naught? 8.854 into 10 raised to power minus 12. Then you can use those values, and then finally guys, you can find the value, and that is what? Negative. That is the charge is what? Negative. So approximately minus 3.4 into 10 raised to power minus 8 you can find. So what is the important about that formula? Formula for depletion charge density. So these 1, 3. And from that you will find this formula. Okay. The next one. Okay, then this is a JFET, right? I have told you that JFET is not in the syllabus of what? Gate examination, but it is in the syllabus of what? JFET is not in the syllabus of GATE, but it is syllabus of ISRO examination and engineering services examination. So tell me, for n p channel J silicon JFET, Na is equal to 3 into 10 raised to power 16, Nd is equal to 10 to the power 18, channel thickness dimension is A. Find approximate pinch off voltage Vp. What is the pinch off voltage Vp here? Okay. Then for a NP channel silicon junction field effect transistor, Na is given, Nd is given, thickness is given. Find the approximate pinch off voltage Vp. Now already I have given what is the junction voltage Vj. That is nothing but Vr plus V0. That is Qn upon 2 epsilon s into W square. W square is the depletion width. When I am talking about the JFET, this is the, what is the channel? P channel, means it is a P type. Here we are giving the N positive, here we are giving the N positive, and this gap is actually 2A. Pinch off means when the depletion layer increases, this is the N channel. This is the depletion layer increases and channel is just pinch off here, right? And that is what is the depletion layer. One sided depletion layer will become A. We have to put the value A here in place of that, and this is called pinch off voltage. So Vr is equal to Vp. Vp plus V0 is equal to Q, right? And that is what lower doping, that is the Na upon 2 epsilon s, right? That is the permittivity of semiconductor into W square. In place of W square you have to put the A square. Then pinch off voltage, approximate pinch off voltage. Here the built-in potential, you have to find the built-in potential Vt log of Na Nd by what? Ni square. Na Nd by Ni square. From that you have to find the Vt. Na is given, remember, Na is given 3 into 10 raised to power 16, Nd is given, that is very high doping in this area, very high doping, that's why it is called N positive, N positive. Na is given, Nd is given, Vt is given, 26 millivolt it is given. Then you can find the value of the V0. Put the value of the V0 here. Q is given, Na is given, again Na is given, A is given 0.33, 2 epsilon s. Epsilon s means epsilon r, epsilon naught. This is silicon is given. You can use the 12 or 11.7 for that. 8.854 into 10 raised to power minus 12 farad per meter, or 10 to the power minus 14 farad per centimeter. Use this value for relative permittivity of the semiconductor, and then finally you can find the value of the Vp. Vp will become Qna by 2 epsilon r epsilon naught A square minus what? V0, built-in potential. So you will get the answer around 1.7 volt. 1.7 volt. But last time that calculation is too high. Remember that, guys. Calculation was too high. So calculators are not allowed. So sometimes we are not able to solve the questions because of the calculation, but no problem. Okay. So if you are able to solve, then okay. Otherwise, try to use what Vedic maths and so on. Fast calculation is required here. Okay. The next one. For a uniformly doped NPN transistor, find the approximate emitter injection efficiency. Guys, again formula based question. That when I'm talking about the transistor, you have to get the idea about the what is the width of the emitter area, what is the width of the base area. Thinnest part is the base. This is what emitter, then that is the base, and that is what collector. This is the emitter, base, and what collector. So suppose it is a uniformly NPN transistor. NPN means this is N type, this is P type, this is N type. This is called emitter junction, that is called collector junction. When this is forward bias, the electron will move, some will recombine here and the remaining will reach here. Right, and at the same time, some hole will move from this point to this point. And because of the hole, current will be in this direction. Because of the electron, current will be in this direction. And the complete current is called emitter current outside the diagram. So, what is the approximate emitter injection efficiency? Eta. Formula. Right. So, there are three factors. Transport factor, get the formula for the transport factor. Get the formula for what? That emitter injection efficiency. So, this is the formula. 1 upon 1 plus dE by dB, that is the diffusion constant in emitter area, diffusion constant in base area, W by LE, NB by NE. Right, concentration in base region, concentration in emitter region, and that is the length and that is the width of the what? Base region. So everything is given here. NE is given here. NB, that is the concentration of emitter is given, concentration of base is given, concentration of collector is given, but that is not required. Diffusion constant, that is the collector region, base region, emitter region it is given, XC is given, XB is given. You have to use the XC and XB in the given question. That is the formula based question, and you can find the efficiency around 0.99. And that is a very, very high efficiency, guys. Very high, nearly equal to what? 1. Nearly ideal condition is what? 1. You are getting the very high efficiency in that case. Then, okay guys, so please use this formula. Use this formula to solve this particular question, formula based question. Now, that is a concept based question. In a p type silicon at 300 degree Kelvin and Na is equal to 8 into 10 raised to power 15 variation of the space charge density in the semiconductor as a function of surface potential is plotted. Variation of the space charge density in the semiconductor as a function of surface potential. Then select the true statement for the weak inversion region, given that rho s and ns are the hole and electron concentration at that surface. When we are talking about the surface, when I am talking that it is a, because we are giving the Na 8 into 10 raised to power 15. But suppose we are applying a gate voltage, that is the positive gate voltage. It will attract electron. At the surface of this semiconductor, that P type is converted into what? N type. P type is converted because the positive will collect the electrons. But there are two inversion. One is called strong inversion and one is called what? Weak inversion. Just the inversion will start it. So that P type is converted into what? N type, but not so strongly. Not so strongly means when we are saying it is the P type is converted into N type means the concentration of electron in that region is greater than the concentration of hole in that region. What is the concentration of hole? PS. But NS is not too strong means it is not equal to Na. It is less than Na. If it is equal to Na, if it is converted into what? Na, then it is called what? Strong inversion. This is called what? Strong inversion. Concentration of electron will become equal to what? Acceptor ion concentration. So which answer is correct? Ns is less than Na. This is the concentration of electron, but Ns is greater than what? Rho, PS. Concentration of electron is greater than concentration of hole at the surface, but it is less than what? Concentration of acceptor impurity. Once it is equivalent to acceptor impurity, that is called strong inversion. Concept of MOSFET here. Concept of MOSFET here we are using. Remember, again theory question. Now the questions from what? Analog. So that is important for electrical and electronics and instrumentation branch. Please ask them to join. In order to ensure that the output voltage of an op-amp is 0 when both its inputs are grounded. Both the inputs are grounded means if this is the operational amplifier, suppose we are connecting both the inputs and this is connected to ground. Under ideal condition, what should be the output? 0. If it is balanced operational amplifier, then output should be equal to 0. But practically output is not 0. We are getting some output, and that is called output offset voltage. Output offset voltage we are getting. Both the terminals are connected to ground. Basically it is a differential amplifier, then output should be equal to 0. But practically we are getting output, that is called output offset voltage. Then what we are doing, we are giving some extra arrangement at the input side, not at the output side. We are doing extra arrangement so that this current will become 0. We are passing the two separate current through this terminal, that is the IB1 and IB2. Right, and finally we want to balance the operational amplifier. Without an input, output should be equal to 0. This we are passing the IB1 and IB2. The average value of this is called bias current. That was the question in ISRO exam. Average value of this is separate current passing through op-amp to balance the op-amp. This is called input bias current, and the difference is called input offset current. Difference is called input offset current. So these are the two formula. So what is the answer for this question? An external offset balancing circuit is used at the input terminal. Internal negative feedback is not, we are not applying. The current incident at the output nodes are carefully designed. No. Totem pole output resistors are designed to have the exactly equal cut-in voltage. Not. That is not relevant. This is relevant. And with the help of external circuit, we are passing two separate current. Average is called input bias current. Difference is called input offset. Okay. That is another good question. Okay. That is on characteristics of the MOSFET, guys. Characteristics of the MOSFET. Okay. Tell me what is the answer. Then watch that. Transfer characteristics of the different types of MOSFET is shown in below, where ID is the drain current, VGS is the gate source voltage, the correct combination of the MOSFET with respect to characteristics. Okay, first is what? P channel enhancement MOSFET. Guys, one by one I will explain. The P channel enhancement MOSFET. In case of P channel, we are giving the negative gate voltage, and it will start from this portion. Enhancement MOSFET means negative. P, that is the 1 is relevant to this, and we are having the negative threshold voltage minus VT for P channel enhancement MOSFET. For P channel depletion MOSFET, again depletion MOSFET, always remember the characteristics will start from this point, and exactly at 0 voltage it will become IDSS, and for some positive value that will, this MOSFET will goes into what? Cutoff. This is called depletion type MOSFET. Depletion type MOSFET. Again, it is a P channel. The 1 and 3. 1 and 3. Now, for N channel enhancement MOSFET. For N channel enhancement MOSFET, the characteristics is like this. Threshold voltage is positive. Means it is related to what? 2. This is the 2. And finally, N channel depletion MOSFET start from what? 0. Negative value. And exactly at 0 we are having the IDSS. Depletion MOSFET, we are having the IDSS. And for positive value it is in enhancement mode. For negative value it is in depletion mode. And that's why this is the fourth. 1324. 1324. C. 1324, that is the answer for this question. C is the answer for this question. Chinmay, it is clear? Okay. 1324. Then next one. Acceptor impurity concentration of silicon at 300 degree Kelvin is 10 to the power 19. Acceptor means Na. Calculate the concentration of donor impurity atom that must be added so that the silicon is N-type and the Fermi energy is 26 millivolt below the conduction band edge. Effective density of state is given, thermal voltage is given. Okay, two things are given here. We have to use the standard formula for this question. This is the EV, this is EC, this is the Fermi level, EF. right? This gap is given by kT log of Nc by N or Nd, concentration of electron. Nc by what? N. Okay. Now you have to find what is given in the question. Calculate the concentration of donor impurity atom that must be added. So that Nd, if you want to make the N channel, Nd should be greater than Na. So what is the concentration of electron? Nearly equal to Nd minus Na. Nearly equal to Nd minus Na. And the Fermi energy is 26 millivolt below the conduction band edge. So this gap Ec minus Ef is given as 26 millivolt. Already it is given as 26 into 10 raised to power minus 3 millivolt. And what is the kT? Again it is a 26 millivolt. You have to find that will become kT log of Nc. Nc, what is the Nc? Nc it is given in the question 2.7 into 10 raised to power 19. In place of N, Nd minus Na, donor minus acceptor impurity, and that is equal to 26 millivolt, and this is kT is also 26, 300 degree Kelvin, the thermal voltage that 26. This 26 cancel, take the inverse log of that 1, and then you can find the value of Nd minus Na, and you have to find the Nd here. You have to find the Nd here, guys. So this is the answer for this question. Okay. What we are using, guys, what we are using the formula. Just I have given you the formula. Use this formula. This one. We are adding extra donor impurity so that the p-type material is converted into what? N-type material. And then use the formula, value, and then you can find the answer for this particular question, guys. Okay. Now, next one. That is the answer, 10 to the power 19 centimeter. Okay. Okay, now question from what? Analog. Another question. For the given amplifier circuit, find the input cutoff frequency. FET parameters are GM, CGS, RDS, CGD, it is given. And then one circuit for the MOSFET, it is given, guys. And input cutoff frequency we have to find. Then internal capacitance are given, that is called high frequency analysis. In case of high frequency analysis, first of all draw the model here. What is the model here? This is the model. Then connect here. This is one capacitor. This is called gate. This is the source. This voltage is called VGS. This is called CGS, right? CGD. This is the drain terminal. Here we are having the GM-VGS. Here we are connecting the RD. And here we are connecting the RDS. RD. This is the RDS, it is given 40 kilo ohm. RD means 10 kilo ohm, 40 and 10 are in parallel. CGS, here we are having one capacitor, that is called CGS. Now here you can connect the RS, here you connect the V. This is the RS 50 ohm and that is the V connected to the gate terminal, and source is connected to ground. This is a common source configuration. That is the model. Now with the help of Miller's theorem, you have to break this. Break the formula. Then it will become V in and simply focus on the input cutoff frequency. It will become CGD 1 minus AV. 1 minus AV with the help of the Miller's theorem. This is the CGS. And guys, when I am breaking the Miller's theorem, you can neglect the capacitance at the output side. These two resistors are in parallel, 40 parallel with the 10 kilo ohm, it is nothing but 8 kilo ohm. Then at this side, we are having only 8 kilo ohm resistor. Okay, and that is called GM-VGS. When we are applying the Miller's theorem, one capacitance will come here. And the value of that capacitance will become CGD AV minus 1 upon AV. And AV is very, very large, negligible, it is nearly equal to CGD. But what is the impedance because of the CGD? It is range of mega ohm. What is the impedance because of the CGD? It is in the range of mega ohm. That's why we are neglecting it. And we are considering only the 8 kilo ohm resistor. When we are considering the 8 kilo ohm resistor, then V0 will become minus GM VGS RDS parallel with RD. And that is, what is the V0 by VGS? V0 by VGS is known as AV. That is minus GM into 8, because the parallel combination is 8. GM is given as 4 into 8, that is the minus 32. Now, to apply the Miller's theorem, always remember the voltage at this point is VGS, voltage at this point is V0, and you have to find the AV, that is called V0 upon VGS. This is called V0. So already I have given, I am just applying the Miller's theorem. We are breaking the capacitor, we are neglecting this capacitor, then we are finding the AV, and then we can find the CGD 1 minus AV. What is the CGD into what is the total capacitance? Total input capacitance is given by CGS plus CGD into 1 minus AV. CGH is given as 2, CGD it is given in the question 2 picofarad. 1 minus of minus 32, that will become 66 plus 4, 70 picofarad. Now, once you will get the input capacitance, what is the cutoff frequency? Just like a RC circuit. Tell me whether it is a high pass RC circuit or low pass RC circuit. It is a high pass RC circuit or low pass RC circuit. This is a VGS. Now, that is the cutoff frequency is given by F is equal to 1 by 2 pi RC. 1 by 2 pi RC, in place of RC, RS 50 ohm. And CI is 70 picofarad. And approximately you will get the 45.5 megahertz. 45.5 megahertz. So that is the formula. That is the formula for that. So it will be cutoff frequency, and this is act as what? Low pass filter at high frequency. Low pass filter at high frequency. Now, this is a Wien bridge oscillator, guys. Next question is on analog. That is a Wien bridge oscillator. In a Wien bridge oscillator, this is R, this is RC dash. RC, this is R dash, this is C dash, and if they are equal, R is equal to R dash, C is equal to C dash, this is called RF, this is called R1. So there is one condition. If R dash is equal to R, C dash is equal to C, then the frequency of oscillation is given by 1 by 2 pi RC. But guys, there is one problem. RF should be greater than or equal to or 2 times of R1. RF should be greater than or equal to or 2 times of R1. What is the R1 here? 1 kilo. What is the RF? 1.9. It is less than that. If the RF is less than 2 times of R1, the circuit will not oscillate. Oscillation will not sustain. That's why the none of this. Condition not satisfied. That's why the answer is none of this. So always remember what is the condition for Wien bridge oscillator. So this is the answer, none of this. Next one. In the given circuit, VB is equal to 0.7 volt, VZ is equal to 5.3 volt, beta is equal to 100 volt, beta is 100, V0 is. That is a question on what, just we can say that is the question on, 1 minute. Yes. Voltage regulator. Voltage regulator means, suppose if you want to find the answer, then watch this transistor. and let the current enter into the operational amplifier is 0. V0 is asked, then simply focus on that. 30 volt is applied here, very high voltage, right? All the answers are less than 30 volt, means circuit will properly work. This is called unregulated voltage, that is called regulated voltage. Then regulated voltage is the voltage across this branch. This is connected to the negative terminal. So what is the negative terminal voltage? If the current enter into the operational amplifier is 0, you can find the Vn according to voltage division rule. 60 divided by 40 plus 60 into V0 means it will become 6 by 10. 6 by 10 into V0. That is nothing but 3 by 5 V0. That is the value of Vn. According to virtual short concept, Vp, that is the Vn, this is the Vp. Vp and Vn are equal. What is the Vp? To find the Vp, apply the KVL from this point to this point only. That is the across the Zener diode Vz, and this is the VBE. This is what VBE. This voltage is VBE. Vz plus VBE, that is the value of the Vp. Breakdown voltage is given as 5.3 volt. It is given as 0.7 volt. That's why it will become 6 volt. Now Vp and Vn are equal. So Vp is equal to Vn is nothing but 6 volt, and that is equal to what? 3 by 5 V0. What is the V0 is equal to? 5 into 6 divided by 3. That is nothing but 10 volt. Answer for this question is 10 volt. Okay, this is the 10 volt is the answer for this particular question, guys. Next, that is the question on voltage regulator. Okay, that is the question on what? Early effect. Question on early effect, base width modulation, channel length modulation in case of MOSFET. Output characteristics of BJT is given, means base width modulation. Find the minimum collector current required for R0 is equal to 50 kilo ohm. R0 is the output resistance. Now guys, this is the, when we are extending the curve on this side, this voltage is called minus VA. From this you can find the value of the early voltage, that is the 50 volt. And what is the formula for the output resistance? R0 is equal to VA upon ICQ. So R0 it is required 50 kilo ohm. VA is given as 50. You have to find the ICQ. What is the ICQ? 50 divided by 50 kilo ohm. This is in volt. So this is what? 1 milliampere. 1 milliampere directly. Direct formula based question. 1 milliampere you can give the output characteristics of a BJT amplifier. That is the question based on early effect. Then again question on what? MOSFET. Again the question on MOSFET. So please like the session and share the link of this session so that the student will join, guys. Okay. Okay, then focus on the board. Then there are two switches. One is S1 and one is S2. So what is the S1 and S2? In the given circuit, S1 switch remain closed and S2 remain open for a long time. Initially it is closed, it is open. T equal to 0, S1 is open, S2 closes and remain in this position for the long time. Find the drain current for T less than 0, for T very greater than 0 respectively. If mu n Cux is 100 and aspect ratio, that is W by L, is 2. So for T less than 0, we will solve this question. S1 is closed. Okay. Then this is the MOSFET. This is the 2 volt. It is closed. Means it is connected to ground. And what is the voltage given? 3 volt. What is the given voltage? 2 volt. What is the value of the VDS? Now, VDS is nothing but VD minus 2. VD minus VS, that is the 2 volt. What is the VGS? VG minus VS. VS is 0, that is what? 3 volt, because VG is given as 3 volt. What is the threshold voltage? It is given in the question. Threshold voltage is 0.5 volt. 0.5 volt. So what is the VGS minus VT? 3 minus 0.5, that is the 2.5 volt. What is the conclusion? VDS is less than VGS minus VT. That's why it is in triode region. That's why it is in triode region. Right. What is the formula for the triode region? IDS is equal to half of, no. In a triode region, K and S, W by L, VGS minus VT into VDS minus half of VDS square. That is the formula for the current. K and S means mu and CUX. Mu and CUX is 100 microampere, 0.1 milliampere. Mu and CUX. Aspect ratio 2. W by L is called aspect ratio 2. VGS minus VT. Already we have calculated VGS minus VT 2.5 volt. VDS is 2 volt minus half of 2 square. That will become minus 2. 2.5, that is 0.1 into 2 into what? 5 minus, this is the 5 minus what? 2. 3 into 2, 6.6 milliampere minus 600 microampere. 600 microampere, because I have converted it into milliampere, so this is the 600 microampere. At this 2, all in 3. But second condition for t greater than 0, that is connected to what? S2. Guys, very simple. You can watch this. When now this switch is open, that switch is closed. When this switch is closed, what is the value of the VGS? VG minus VS. This time VG is 3 volt, VS is 4 volt minus 1 volt, that is less than the threshold voltage, and that's why it is in cutoff. So in second case for t greater than 0, it is in cutoff, that's why the current is 0, and the A is correct answer. 600 microampere for first case and 0 for second case for t greater than 0. That is the explanation. Now, this is the question on what? Symmetry trigger circuit. This is the question on symmetry trigger circuit. What is the asked here? Now, there was the printing mistake in answer. In the circuit shown, diodes are ideal. Which is the correct representation? Or when this path will work, so what is the threshold voltage? VUT H minus is equal to VB1 is equal to, this diode is on initially 4 upon 2 plus 4 into V0, and what is the initial V0? 10 volt. 10 volt. Then it will become 2 by 3 of 10 volt, that is the 6.67 volt. This is called upper threshold. So initially the diode D1 is on, D2 is off. For V0 is equal to 10 volt. For V0 is equal to minus 5 volt. D1 on, D2 off. This is the D2, sorry. So D2 on, D1 off. Now this time 2, 4, it will become 2 by 4 plus 2, that is the 6 into minus 5. And that has become minus 5 by 3, that is nothing but 1.33, 1.66, no, 1.67, right? Then yes, you can calculate it, minus 10 by 3 or minus 10 by 6, 5 by 3, 1.67. Okay, then that is the lower threshold, this is the upper threshold. You will get this type of curve, hysteresis. When the input is given to negative terminal, you have to give the two values, 6.67, right? Yes, 1.67. First of all, it will increases, then it will cross the lower threshold, sorry, upper threshold, and then it is negative. The second case, it will like this. This is the transfer characteristics for this one. That is the path, clockwise direction. number of session I have given why it is in a clockwise direction. So upper threshold is 6.67, that is the 10 by 3, and lower threshold is minus 5 by 3 according to the given data. Oh sorry, this is a mistake, sorry for that. According to voltage division rule, it is a 4 divided by 2 plus 4 into minus 5. 4, this is the 4 divided by 2 plus 4 because this resistor is give the voltage. So 4 divided by 2 plus 4 here, 4 divided by 2 plus 4 same. Then it will become minus 20 by 6 minus 10 by 3. What is the minus 10 by 3? Minus 10 by 3 is nothing but minus 3.33. This is the answer, minus 3.33. This is what, plus 10 volt, and this is minus 5 volt, remember. Because the lower voltage is minus 5 volt, so this is the minus 5 volt, this is the 10 volt. So this type of graph you will get, this type of graph. But what is the answer given in the question? In the answer given in the question in ISRO examination, no doubt it is in anti-clockwise direction. This is the 10, this is the minus 5, everything is fine. But this value is wrong. In this place, you have to use the minus 3.33. That's why we have given you the right answer. That is the answer. This is the answer for this particular question. What is the wrong in this answer? 10 minus 10. 10 minus 10, that is wrong. Right? What is the wrong in this question? 10 minus 10, that's why these are wrong. What is the wrong in the question? 10 minus 5, threshold voltage, all are right, but it is given in anti-clockwise. Rotation is given in anti-clockwise, that's why it is wrong. And this is the correct answer. It is in a clockwise direction. When input is given to inverting terminal, clockwise direction, guys. Okay. So sometimes in every exam there is a marks to all type of questions, printing mistakes and so on. Don't waste your time. Now, consider the AND logic circuit in which V2 is equal to 3 volt, V1 lies between 0 to 5 volt, V2 is 3 volt, V1 is what lies between 0 to 5 volt. 0 to 5 volt, V1 will vary. It will increase from 0 to 5 volt. The cut-in voltage of the diode is 0.6 volt. The output voltage V0 versus V1, because V1 is vary from 0 to 5 volt. In a x-axis we are having the V1 and on y-axis we are having the V0. The output V0 versus V1 corresponding to the below network is according to this network. So very, very simple one. Okay. So please solve this question and give me the answer, guys. Give me the answer. What is the answer for this one? Try to solve this question. Sound is okay? Done? Hello? Yes, I think everything is fine now. Then, in this question, always remember for diode, this is the diode. One resistor is connected here, 5 volt. And this is the V0. For example, V1 is 0 volt. Second diode, V1 is 3, V2 is 3 volt, fixed. It is variable, so I am taking the 0 volt. When it is 0 volt, it is less reverse bias, it is more reverse bias. And because of the 5 volt, initially it is on. When it is on, the drop is 0.6 volt. And this is the 0 volt. So what is the V0? V0 is equal to 0.6 plus V1. That is the general answer. When the D1 is on, D2 is off. D1 on, D2 off. That is the general answer, 0.6 plus V1. And initially that voltage is 0.6 volt. Okay. And since this is the 0.6 volt, definitely 0.6 volt is less than 3 volt. That's why this diode will remain off. Now, when the D2 will on, the D2 will on when the V0. This is the reverse bias volt 3 volt. When the V0 is greater than or equal to 3.6 volt. When the V0 is greater than or equal to 3.6 volt, D2 will on. D2 will on. So what is the value of V1 for which the D2 will on? So V0 is equal to 0.6 plus V1. 0.6 plus V1, that is equal to 3.6, means V1 is equal to what? 3 volt. Means when the V1 will increase from 0 to 3 volt, so I can give the range from 0 to 3 volt. Diode D1 will remain on, D2 will remain off. And what is the output? Output is 0.6 plus V1. But once the input V1 is greater than or equal to 3 volt, this is off, that diode will on. Once this diode is on, this is the fixed voltage 3 volt, 0.6 is fixed, this is fixed, that is fixed, and that's why the output is also fixed. Output is fixed at 3.6 volt. Output is fixed at 3.6 volt. So that is the characteristics. Now you can draw from 0 to 3, 0.6 plus V1. Exactly for V1 0, 0.6, and it is the equation of the line. So when it is the equation of the line, which is satisfied here, for 0 to 3, it will start from the 0.6, but it is the break point is what? 3.6. That's why it is wrong. It will start from the 0.6 exactly at 3 volt. It will become constant. That is the right answer. B is the correct answer. It is always linear. That's why it is not the right answer. It is decreasing. That's why it is not the right answer. Which answer is correct? B is the correct answer for this particular question. 0.3 and so on. Okay. Then next one. Next question. And this is the last question. After that, the Saket sir will join you to continue with this session, guys. Okay, and Rakesh sir will take the question, important subject. Okay, then. Now, the Zener regulator circuit shown below consists of the silicon-based Zener diode. This is the silicon-based Zener diode, and the germanium diode. Germanium diode. The cut-in voltage of germanium diode is 0.2 volt. Whereas the cut-in voltage of the silicon diode is 0.7 volt. That is cut-in means when the diode is forward biased. What is the breakdown voltage? 10 volt. And what is asked here? The output voltage V0 of the Zener regulator circuit is. Output voltage of the Zener regulator circuit is. Always remember, guys, in this case, this is the Zener diode and it is a positive voltage. When we are having the positive voltage, the current will flow like this. This diode will be breakdown. This diode may be forward bias. When it is breakdown, the voltage is 10 volt. When it is forward bias, what is the cut-in voltage? 0.2 volt. So what should be the voltage at this point? 10.2 volt. What should be voltage at this point? 10.2 volt. So number of students will give the answer 10.2 volt. But to make it break down and to make it forward bias, the voltage at this point should be sufficient. So initially this two will act as open circuit. So what is the diagram here? One minute. Okay. That is the 20 volt. It is given. It is 20 ohm. It is given. It is 20 ohm. It is given. Guys, so what is the output voltage? Output voltage is 10 volt according to voltage division rule. Now, what is the voltage required here? 10.2 volt. So this 10 volt is less than that. That's why this diode, silicon, is not in breakdown and that diode is not forward bias. This path will not work. This will act as open circuit. And the current will pass through this and output is fixed at 10 volt. So always you have to check whether the sufficient voltage is present here or not present. So guys, So this is the answer for this question. Okay, so that is the questions from analog, guys. Now the Saket sir will join you. So give me 1 minute. So please stay tuned with us. 1 minute. Please stay tuned with us.
Hello, good evening, everyone. Sorry, good afternoon, actually, because it is 2 o'clock now. Now it is not 4 o'clock. So I hope that all of you have already solved the 62 questions of the ISRO examination paper. Now you have got a good idea that how to approach to the question and which kind of questions asked in the last year. So here we are going to solve the questions from the communication and EMFT. So let's start the session with the basic first question, which is our communication and EMFT. Okay. So are you ready to solve the question? Come on, guys, quickly tell me. Are you ready to solve these questions? Okay. So this is the first question in front of you. That is the plane wave propagating through the dielectric has the magnetic field component, and we have to find the determine the polarization. So what is the polarization? Polarization occurs in the direction of electric field, and how do we calculate the direction of electric field? The direction of electric field is cross product of direction of magnetic field and direction of wave propagation. So what is the direction of magnetic field? The direction of magnetic field is y, and the direction of wave propagating is x. So the direction of magnetic field is y, and the direction of wave propagation is yes. So that is ay cross ax, which is minus az. So the direction of polarization is minus az. So answer B will be the right answer for this. Now coming to the second question, in a free space H is given, and we have to find the total power crossing through this particular plane. So what is the equation of the plane? If I write the equation of the plane, it is x plus 2y minus 1. So if I want to calculate the normal vector to the plane, it is nothing but the gradient of the phi and the magnitude of phi. So if I calculate the gradient, this is 1 into ax plus 2 into ay divided by root 5 is the direction. And what is the direction of electric field? The direction of power crossing, or that pointing vector. The direction of power crossing is in the direction of wave propagation, which is x. So when we calculate the dot product an cos ax, we get 1 upon root 5. Now how do we calculate the power? The power, average power, is nothing but the integration over the surface time average pointing vector dot ds. So let me write here the power only, not P. I am representing the power crossing is by P. So this is nothing but the integration over the surface time average pointing vector magnitude. So we know that E naught square upon 2 eta is the power, and E naught is equal to eta into h. This is the power density. So eta naught into h whole square divided by 2 eta. So you can write the time average pointing vector as eta into h naught square upon 2 into direction of propagation, and this is the direction of normal vector like a n cap. This is A n cap. Area, the magnitude of the area and A n cap. So when we calculate it, this is eta. Eta is nothing but a 120 pi because it is given as free space, and h naught square is 0.1 whole square divided by 2. What is the area of this particular plane? That is 10 centimeter square. So 10 centimeter whole square, because the square side is given, the square plate is given, and the dot product is 1 upon root 5. AK dot AN has the dot product, AK dot AN has the dot product 1 upon root 5. So when you solve all this, you will get 8.425 milliwatt as the answer. So this is the power crossing through the particular plane of a side, square side of 10 centimeter. Now, what is the consider of rectangular cavity? Actually, this is the question from the microwave, but let's because we wanted to cover the all the 80 questions, so I have kept in the EMT. But the rectangular cavity you have to study in the microwave communication. So, according to that, the cutoff frequency is actually given by C upon 2 root over C upon 2. This means we can write the velocity also, velocity Vp. So this is nothing but a m by a whole square plus n by b whole square, and let's say n and m and q they write is as q. So q upon c whole square. So because the a and c are same, so a and c are same, and because the b is minimum, so for b minimum we have to choose the n as 0 and m equal to 1 and q equal to 1. So this is the cavity which is having T, E, M and Q, or M and P. You can also represent by M and P. So that is GE 101. 101. That is the right answer. Option B will be the right answer, Chinmay. 101. Now coming to this question, this is the question from the antenna array element. Here we have the output of a 3-element collinear antenna array. So here we have the 3 antenna elements, and they are shifted, placed by lambda by 2 distance apart. And then the free space environment is given. Space element is lambda by 2, and the maximum response is 30 degree. Then how will you calculate the overall phase difference between the element? So if I draw the perpendicular line from the second element to the first element, this is the 90 degree. So this is the lambda by 2. What will be this angle? This is the 60 degree. So this will be your D. This is your nothing but the distance is D. So this is D cos 60 degree. And when you draw the perpendicular line to calculate the phase difference from the third to first, that is the 90 degree, and this is again the 2 cos theta. So that means 2d cos theta. What is the phase difference? We calculate the phase difference by beta d cos theta. Okay, we calculate the phase difference by beta d cos theta. So the difference between 1 and 2, the difference between 1 and 2, the beta is 2 pi by lambda, the distance is lambda by 2, and the angle is 60 degree. So cos 60 is root 3 by 2. So first of all, lambda will get cancelled, and this is pi, and cos 60 is 1 by 2, in fact, not root 3 by 2. So we will get the pi by 2. So the phase difference between first and second is pi by 2. And what about the phase difference between 1 and 3? So 1 and 3, we will again use the same formula beta d cos theta, but this time d is the distance 2d cos theta. So b is 2 pi by lambda, and this is 2 into d is same lambda by 2, and the angle is also same. So now if I calculate, this is just coming as 1. So it is coming as pi by 2 or not 1, that means pi it will come. Okay, because this 2 and 2 will get cancelled, lambda will get cancelled, and cos 61 by 2 will get cancelled. So pi by 2 and pi. So if the first one is having the phase 0, then the second one is having the phase pi by 2, and the third one is having the phase pi. So correct answer will be option C. Okay. Now coming to the next one, we have the transmission line, and we have the impedance of this line as 200, and this transmission line has the load 200, and the characteristic impedance is given as Z0, which is 50. So this characteristic impedance is given as 50. So let's calculate the reflection coefficient for this. So this is ZL minus Z0 divided by ZL plus Z0. So this is 200 minus 50 divided by 200 plus 50. So that is your 150 upon 200, that is 3 by 4. So the VSWR of this line is 1 plus magnitude of reflection coefficient divided by 1 minus magnitude of reflection coefficient. So 1 plus 3 by 4 divided by 1 minus 3 by 4. Wait, I think I have done one mistake. 250 characteristic impedance of the line is 50. So 200 minus 50 is 150 and 250. Okay, sorry, this is 250. So this is 250. So 0 0 get cancelled and this is 3 upon 5. So we are getting 3 upon 5. So we have 8 upon 2, that is 4. So VSWR of this line is 4. So VSWR for this transmission line is 4. So VSWR on the transmission line section length D is 4. Okay, now we have to calculate for the stub also. So reflection coefficient for stub is the ZL minus Z0 upon ZL plus Z0, because the load is short circuited, so the load is 0 for this. So reflection coefficient we will get 1, and according to the VSWR formula we will get infinity. So answer is 4 and infinity. Now we have the magnetic current. Okay, we have the sheet which is having the magnetic current. So this is the sheet we are having, and the magnetic current is flowing, which is mm, represented as K is equal to minus 20. So we want to calculate at y is equal to 10. So from y equal to 0 to y equal to 10, we want to calculate the point where y is 10. So we are moving in the upward direction. So the magnetic field intensity is 1 by 2 into K cross AN. So 1 by 2 into K. K is minus 20 K cap, and normal direction is y. And that is in the positive direction. So J cap. So this is minus 10 K cross J, minus 10 K cross J is minus I. So we will get 10. So 10 milliampere per meter. So 10 I cap. This is I cap. So 10 milliampere per meter. So answer is option B. Okay. Coming to this next one. Here it is given that there is a conducting sheet. Okay, this is the conducting sheet given to us, and above this we have a charge of 2 coulomb of some height 1 meter. So that whenever we have the grounded conducting sheet, we use the method of image, and we replace it by the equipotential surface, that is 0, and we place the charge just below the sheet in the same height as the magnitude minus 2 coulomb. This is the method of image. Now the distance between these two is 1 meter, and 1 meter become 2 meter. So the force is given by 1 upon 4 pi epsilon naught or epsilon. Okay, 1 upon 4 pi epsilon, and then Q1 Q2 upon R square. So 1 upon 4 pi epsilon, Q1 is 2 into minus 2 divided by R square, that is 2 square. So in this way we will get 1 upon 4 pi epsilon. Because the sign is not important, because we have to write only the magnitude. So 1 upon 4 pi epsilon naught epsilon is the right answer. So option A. Okay, the magnitude you can write, because in the all the options we don't have to worry about the magnitude. Now this is another question in which a mobile antenna receives the two copies of the signal transmitted by the base station. The first copy of the line of sight component, and other is the reflected component. So one is the direct component, another is the indirect component, and weaker in terms of power than the loss line of sight component, and delayed by the 100 nanosecond. And if the signal is sufficiently wideband, causing the constructive and the destructive interference at the different points within the signal bandwidth, what will be the ratio of the maximum to minimum? That means the VSWR, and what is the frequency of the separation we have to calculate. So how can you calculate the VSWR in this case? Because it is saying that the 20 dB loss, so we can say that the return loss we have is minus 10 log of magnitude of reflection coefficient. So this is given as 20. So minus 10 log of magnitude of reflection coefficient. So when we solve this magnitude of reflection coefficient 20 log of 2, that is, what will be the reflection coefficient? 0.01. Okay, so we will get, because of minus sign, 0.01 we will get, and the VSWR is 1 plus magnitude of reflection coefficient divided by 1 minus magnitude of reflection coefficient. So this is 1.01 and 1 minus 0.01. So when you will solve it, obviously this is 101 divided by 99. So these two options are eliminated, B and D, and now we are left with A and C. Now the delay is of 100 second because it is traveling the two way. So the total delay will be 2 into 5. Okay, because the maximum and minimum gap, it wants to calculate the maximum or minimum. So we have to calculate it as a lambda by 2. So from here we can say that because the delay is 100 nanosecond, we are getting the frequency as 1 upon 200 nanosecond, that is equal to megahertz, 5 megahertz. So 5 megahertz we are getting, so that is just double. So that is double means 2 into f. So the separation is lambda by 2. So corresponding to that we will get 2f, that means 10 megahertz. So we have the answer as option number A, 10 megahertz. Maximum to minimum gap is lambda by 2. So the frequency gets double. Actual frequency is delayed by 100. So it is traveling the two-way propagations. So 100 nanosecond plus 100 nanosecond is total delay of 200 nanoseconds. So corresponding to 200 nanoseconds, we will get 5 megahertz, and that 5 megahertz is the frequency. Now we want to calculate the frequency for maximum to minimum, so the frequency will get double. Now what is this question? An antenna gives antenna with a efficiency of 90% has a maximum radiation intensity of 0.5 watt per steradian, and they calculate the directive gain when the input power to the antenna, it is written double, is 0.4. So the efficiency is given as 90%, and 90%, that means the radiated power divided by input power. So how can we calculate the radiated power, because the input power is given? So 0.9 into 0.4, that is 0.36. So that is the radiated power. Now what is the formula for directive gain? That is nothing but a 4 pi into maximum radiation intensity divided by radiated power. So this is nothing but a 4 pi into maximum radiation intensity is given as 0.5 and radian is 0.36. So now when you will calculate, let's calculate, and yes, we will get 4 pi into 0.5, 0.36, yes, 17.44 we will get, correct. Option B. Now coming to the next one, 72. What is the radiation intensity? If the U theta radiation intensity is given, then what is the directivity actually? The direction, it is directivity. So the directivity we can calculate directly from the radiated power is given by integration u theta comma phi, double integration we can say, u theta comma phi sine theta d phi, correct. Now because the range is given, so phi is from 0 to pi, it is only the sine phi, 2 is constant which is outside. Now theta is also 0 to pi, and it is sine square theta, because sine theta is already given, and here is also sine square theta. So this is d theta. Now when you solve it, this is 2 into 2, and we can write the phi equal to 0 to pi by 2 sine phi d phi, and this is also written as 2 times theta is equal to 0 to pi by 2 sine square theta d theta. Now by the formula of the reduction formula, that is 1, and because it is odd, so this is 1 upon okay, you can directly calculate, the power is 1. Let me write like this. This is minus cos phi, and 0 to pi by 2. So when and what about this? This is 2. So 2 minus 1 1, and it is pi by 2 also divided by 2 into 1. Yes. So that is the result of this integration. Now 8 and cos pi by 2 0, and cos 0 is 1. So this is 8 into pi divided by 4. So we are getting 2 pi. So we will get the power radiated as 2 pi. The directivity is 4 pi into maximum radiation intensity divided by radiated power, same as the last question. So 4 pi into maximum value is 2 divided by radiated power is 2 pi, so this is 2, so the directivity we get is 4. So let's check once, check the calculation. Yes, so directivity we get 4, and because we want to calculate in the dB, so directivity in dB is 10 log of 4, which is equal to 6 dB. So answer is option number B. Now this is the question from the radar again. So how will you approach this question? A radar receiver has a detection. So quickly try to solve this by the using the radar equation. Actually, this question is from radar, or you can say also from the satellite. So generally G by T ratio concepts is coming here in this question. So generally in this type of question we get the concept of radar or satellite communication, you can say. So we know that the power received is given by PT into GT square, which is the gain of the transmitting and the receiving antenna, if both are same. So lambda square into sigma upon 4 pi whole cube divided by R to the power 4. Okay, and we know that the signal to noise ratio, because here it is given about the signal to noise ratio also. So we have to think of signal to noise ratio. So how can you get the signal to noise ratio? Because it is saying a signal to noise ratio 10 dB. So that is why the signal to noise ratio, the signal power is PR and the noise power is N naught into B. And how can you calculate the noise power? The noise power is K into T into B. So from here, if I write this signal to noise ratio, the power PR, the value of PR is given here. So when you will substitute all the values, you will get PT into GT square into lambda square into sigma upon 4 pi whole cube into R to the power 4 into T into B. Now, because we want to calculate the signal to noise ratio in dB, then this formula will become SNR is equal to EIRP, effective isotropic radiated power, plus G upon T. Okay, this G and T, this T we will take together. So G upon T we will get, and these all are in dB. So minus K, 1K I think left. Okay, so this K minus T. Okay, T we have taken, so minus B actually. Okay, and then after that we have the lambda square upon 4 pi whole cube into R to the power 4 plus sigma. So all are these things in we have to calculate. Okay, we have to substitute all these values. So SNR is given as 10 dB. This is the SNR. This SNR is given, and apart from this we have the EIRP. EIRP is there. EIRP, yes, EIRP is 40 dB. So EIRP is given. SNR is given. What about G by T? G by T is given. K, value of K is constant, which is also it is given in the form of log. So we will take the 10 log. We will get that. Okay, and this range is also given. Okay, the range is also given, the frequency is also given. So here also we will get the values, and now this is only one thing which is left is sigma. Okay, that is only one thing which is left is sigma. So when you will solve it, you will get the sigma is equal to 10 minus 40 minus 10 minus 228.6 plus 66 plus 193. For this lambda square upon 4 pi R to the power 4, you will get the 193. Okay, with the minus sign. And sigma we want to calculate, and what we have given, yes, rest of the things we have given. The bandwidth, so for the bandwidth, this is given, log 4 pi is also given, so from here also you can calculate. And bandwidth is here 4 megahertz is given, so this B you can utilize and calculate. So in this way you can calculate, and you will get the sigma is equal to how much? Minus 9.6 dB meter square. So that will be our answer, option number C. Okay. Now coming to the next one. Here what is given, the electric field between the two parallel plates placed in the vacuum is E. If a slab of dielectric constant root E is inserted in between the plate such that the tan theta, the normal to the boundary, makes the angle 45 degree, then the line of the electric field falls between the planes. Find the angle between the electric field lines. So we know that this tan theta 1 divided by tan theta 2 is equal to epsilon r1 divided by epsilon r2. So first is vacuum and angle is 45. So tan 45 divided by tan theta 2 we want to calculate. First medium is vacuum, the second medium is having the dielectric relative permittivity root 3. So from here if I calculate this, theta 2 is 60 degree. So it is making the angle with the normal. We want to calculate the angle with the medium between the plate and the dielectric slab. So the angle between the plate and the dielectric slab is theta 2 minus theta 1, which is 15 degree. Theta 2 is 60, 60 minus 45, which is 15 degree. So that is our answer. Direct question is there. This is the direct question. Now coming to this part, the two parallel perfectly conducting plane infinite extended are placed at a distance b apart so that the cutoff frequency of the lowest is 15. If additionally two perfectly conducting planes are placed 10 millimeter apart to make the rectangular waveguide, then find the cutoff frequency of TE11. So for the parallel plate waveguide, what is the cutoff frequency, guys? For parallel plate waveguide, what is the cutoff frequency? Because it will be solved after that, because once you get the dimension, then we will directly apply the formula for the rectangular waveguide, so that will become easy. For parallel plate waveguide, this is simply because only one mode is there, only one side is there, two plate is there, so we will have to depend on only one side. That is, FC is equal to cutoff frequency is MC, or you can write, okay, let's write MC upon 2B. The bit, this dimension is given now. So we have the cutoff frequency for this mode 15 into 10 to the power 3, and M is 1, and C is 3 into 10 to the power 8, and 2 into B. So this B we want to calculate. So this B is, when I am calculating 15 into 230, yes, this will get cancelled. So we will get 1 centimeter. Okay, we will get 1 centimeter. So B we have got. Now A is already given. A is given as 10. So let's substitute all the values in for the to form the rectangular waveguide. So this is nothing but a C upon 2 root over M by A whole square and N by B whole square. This is 3 into 10 raised to power 8, or let's write 10 because we are writing in the centimeter. So 10 raised to power 10 divided by 2 and root over 1 upon A. A is centimeter. If you will write, this is nothing but a 10 to the power 100 centimeter plus, in fact, 1 centimeter. 1 centimeter. This is also 1 centimeter whole square. So 1.5, yes, 15 root 2, 15 into root 2 gigahertz. This we have converted into the centimeter, which is 1 centimeter, and this also 1 centimeter. So when you will solve it, you will get the 15 root 2 gigahertz. That is our option number C. Okay, that is our option number C. Now let's come to the questions of communication. Here you can see that a video camera generates a data at a rate of 5 Mbps. The data is channel coded at rate 1 by 3 and 8 PSK modulated. Which of the following statement is correct? So because the code rate is given in this question, so code rate is given as 1 by 3, that means the formula for code rate is K upon N. So that means for one message bit we are transmitting 3 code word. So that is 1:3. So how much we are actually transmitting? This is 5 Mbps. So 5 Mbps we are actually transmitting. The data is 5 Mbps. So the information rate will be, as you can see, the data is 1, then the information rate is 3. So when we are transmitting the 5 Mbps, then information rate would be 5 into 3. That means 15 Mbps. So 15 Mbps will be the information rate. Now because we are using the 8 PSK, so what is the symbol rate? The symbol rate is information rate divided by log base 2 number of levels we are using in the PSK system. So that is 3. So again it is coming as 5 MSPS. So 5 mega symbol per second. So answer is option number B. Information rate 3 times and the symbol rate is information rate divided by log base 2 M. What is the symbol rate? Symbol rate is nothing but the bit rate divided by the log base 2 number of bit we are using per level. So we are using 8 PSK, that means we are using the 8 amplitude levels. So that means the number of bits required will be 3. Now which one of the following is not a valid code word for this? For this particular code, this is which one of this is not valid code word. So how many data can be corrected? We can directly calculate because the minimum distance we can calculate. Here it is said that cannot be the valid code word of the same group. So the minimum distance will be 3. The minimum distance would be 3 here. Check once and let me know. Quickly. Because it is written that this is the Hamming code. For the Hamming code means Hamming code is a only single bit correcting code. It can detect two errors, but it can correct only single bit single bit correcting code. So that means the t is equal to 1. So the d minimum is how many bits it can be corrected? So this is 2t plus 1. So we know that this d minimum is greater than equal to 3. So minimum distance should be 3 or it should be greater than 3. So for the first option, this is 0001011 and the second option is 0011101. So how many position it has the change in bits? So that is the first position. It has the change. This is the second position. This is the third position. So the minimum distance is 3 for option number A. Similarly, when you calculate for option number B, 0101100 and this is 0001011. So the number of position it has changed 1, 2, 3 and 4. So here also minimum distance is 4. So it is maintaining this condition. Now option number C, 0001011 and it is 0011010. It has changed in the first position and this is the second position. So here the d minimum is 2. So d minimum is 2, that means it is violating this condition. So if this condition is violating, that means it is not a valid code word. So option C will be the right answer. It is not a valid code word. Not valid code word. You can calculate for the fourth option also. So 0001011. This is 1110100. So it has changed in this position, almost in every position it has changed. That means it is just a 1 bit complement, okay, one's complement. So that means all the bits are changing. So minimum distance is greater than 3. So it is also satisfying the condition of single error correcting code. So the answer will be option number C. Now, which one of the following digital modulation can be used non-coherently? So, non-coherently, we have two methods for the FSK, coherently and non-coherently. So, the answer is BFSK. And this one, a source is generating the 4 messages M1, M2, M3 with the probability 0.5, 0.25, 125, 125. The messages are generated independently of each code word. A source code assigns binary code to each message. Which one of the following has the minimum average length? Minimum average length. So, for the option B, you can see that because this uniquely decodable, it should be there. So this is 0, this is 0, 1, 1, 0, 1, 1. So there is no code which is repeating. But here, if you will see this 0, 1. So this 1 is in the prefix of this particular code. So this cannot have the minimum code word length, or it is not a valid code word which is uniquely decodable. For the uniquely decodable, no other bit should be in the prefix of any other code word. Here you can see that this is 0, 0, but it is not present in any other code, right? It is 1, 1, 0, 1, 1, 0, 1, 0 and 0. So it is the single bit 0, but you can see that in all the other 3 bits, it is not in the prefix. Here also this 0 is the single bit, but in the other, it is not in the prefix. So that means all the A, B and C are uniquely decodable. B is not uniquely decodable. Okay, so the condition first, our condition was that it should be uniquely decodable. Okay, so it is given that it is uniquely decodable. Minimum average length which is uniquely decodable. So option B is not uniquely decodable. So we will not calculate the average code word length for option B. For option A, option C and option D we can calculate. So I will give you the formula to calculate the minimum average code word length. That is the summation I is equal to 1 to n. That is the ni number of bits and the probability. So for the option number A, we have the 2 bits and its probability is 0.5. We have the 2 bits in the second code, its probability is 0.25. And we have the 0.125 multiplied with 2 and again the 0.125 multiplied with 2. Similarly, you calculate for the option number B and let me know what is, sorry, option number C, B cannot be there. So this is 3 bits in the final code and the probability is 0.5. Again 3 bits 0.25, 2 bits 1 to 5, 1 bit 1 to 5. For option number D, 1 bit with 0.5 probability, 2 bit with 0.25 probability, 3 bit for 1 to 5 probability and 3 bit for 0.125 probability. So in this way you will get all the 3 options and you just need to tell what is the minimum code word. So we have to calculate one by one. For first option, we are getting 2. For the option number C, I am getting 2.625. And for option number D, I am getting 1.75. So I am getting the minimum for option number D. I am getting the minimum for option number D. Okay. So guys, don't forget to join the scholarship test on 18th of June at 12 o'clock and don't forget to register yourself for this particular scholarship test. You will get so much benefit when you join the complete course of uh, BYJU'S with GATE and ESE preparation. Okay, so let's meet on the any other session and thank you for watching this session. Stay tuned with us and also join in our Trigopedia session and subscribe our channel. Thank you.